Agora
It's
tá
the
indo.
second flag of Luxembourg.
Oh, okay. I didn't even realize that. Okay.
We are live?
No,
All right.
moment.
Sweet.
Not yet?
Not yet. Now it's live.
Okay. Hello, everyone. Good morning, good afternoon, good evening. Because as I said yesterday, we are covering a lot of time zones, so to not exclude anyone. So welcome to the third day of Luxembourg Oracle user group. So we will have one more day with presentations tomorrow. But for today, we have Sandesh, Robert, Alexa Bala, and Mari Kupatadze. The name, I hope I said correctly. Mari, forgive me if I said incorrectly. Please let me know later. So let me just jump to the other screen. So we are founded in 2019. We have more than 100 members right now. If you are not subscribed to our membership on portal, please do it. It's totally free. We have a lot of articles published there, some videos, some webinars that we publish along 2019 and some webinars in 2020. So I will give the word right now to my great friend Sandesh Hao from Oracle. Sandesh is with you right now.
All right. Sweet. Thank you so much, guys, for this opportunity to present. Give me a second. Let me just share my screen.
I will stop to share mine. Sorry.
All right.
I need to.
Thank you so much, man.
Okay. Now you can do it.
All right. I'm assuming you can see this.
Yes, perfect.
All right. Well, good morning, good afternoon, good evening, whichever part of the world you're joining from. Thank you for this opportunity to present. My name is Sandesh. I've been at Oracle for 20-something years. I worked on all sorts of different spaces, from databases, grid infrastructure, different kinds of languages. I've done development, I've supported customers, I've been on site. I worked on enterprise manager. So I've actually worked on a whole swath of products. But the last couple of years, I've been concentrated on more on using AI and machine learning for the Oracle Autonomous Database in the backend, for doing most of the AI ops based management and operations. This presentation is going to focus on a different aspect. It's going to concentrate on AutoML and data science using the Oracle Autonomous Database. So we've released this thing called OML, the Oracle Machine Learning piece of infrastructure as part of the Oracle Autonomous Database. I'm pretty sure you've seen this in many presentations, where you can actually write some simple pieces of SQL code, and you can do all sorts of interesting machine learning on top of the existing data you have. This presentation kind of starts from there and takes it to the next level as to what is AutoML and what is actually coming in the subsequent versions of Oracle. So the agenda here is that we're going to talk a little bit about ML and the overview. We're going to talk about the journey of the DBA to the data scientist and what are the various things that you need to do to go from DBA to data scientist. We're going to have some examples of OML, and then we're going to talk a little bit about what AutoML is, what's coming, and what is this thing going to do, and what aspects of machine learning is this thing going to automate. And then we'll have questions. Feel free to type your questions in chat as we go. We'll also have some time to do this at the end of the presentation, but if you type your questions in the chat as we go, I can answer all of them at the end of the presentation. So the first thing is, it's like today, traditionally, DBAs are responsible for two major tasks. One of them is all the maintenance tasks, which is configuration, tuning, setting up of network storage, provisioning, database backup recovery, optimization. And then the second aspect of it is, planning architecture, doing data modeling, doing security, application lifecycle management, and stuff like this. So as we moved more and more towards the autonomous database, more and more of the stuff that was at the bottom for maintenance tasks kind of started going away. And people needed to concentrate more and more on data modeling, architecture, data wrangling, and then writing all sorts of different reports using BI and AI to be able to make the data more valuable to their business. So 4 different roles started emerging as part of this whole conversation. The first one was the data engineer. The data engineer is the person And I think yesterday, my buddy Kamran explained it very well when he was talking about what data architects do and all of these other different roles that have been created as part of this transition. And the data engineer in this case is the guy that makes the data available to the data scientist, the person who does not do the actual machine learning themselves, but they're responsible for making vast amount of swathes of data organized in a manner that can actually be consumed by the data scientist. Then there's data scientists themselves who basically look at this data and they try to solve these problems by making predictions. Then there's a data security role where data classification and lifecycle management come in. And then there's obviously the application tuning role, which is going to be there for a long time to come, where people go into SQL tuning, connection management, scale up, scale down, all of those kinds of activities. A little bit more into details when you're doing when you're a database developer and you're already doing most of this work because you're already doing data extraction, you're doing classic ETL, you're data wrangling, you're doing these deriving new attributes, right? Which is also called feature engineering as part of machine learning. So a lot of time is actually spent in cleaning up and organizing and bringing all this data, which is usually not as efficient, but it's something that we always do. The second part, which is trying to come up with predictions and insights and translating and deploying these models. This is actually the interesting part, where the data management platform comes into being. And that's where you want to concentrate most of your efforts as part of the machine learning features that we have. So organize data, wrangle them, try to come up with the feature attributes, and then import all these predictions and translate it, build your ML models. So this is a typical flow. Over the years, what's been happening is people have been taking all sorts of data and they've been converting it to predictions and insights with machine learning. So something that started off with Apex reports and dashboards, then it goes into diagnostic analysis and reports. You basically want to know why it happened and what are the details of what happened there. And then you want to know what is going to happen. So you go into predictive machine learning, right? You want to figure out when should I buy something at a particular location? Is it a good time to buy a house? What should I invest in the stock market? All these kind of things that are coming up. And then now it's like automated machine learning apps, right? I'm trying to sell something to somebody. Automatically, it scans my friends to see which ones of them are in that category. And it says, hey, you can sell this to your friend here because this person is working in a field that is matching to a product that you want to sell. So the apps kind of taken to the next level by using whether it's predictive analytics, machine learning, social graph, and then try to enable the applications to make them completely ML enabled. So this is a transition that has happened where people have gone from complete dumb reports to complete ML enabled applications. Now, when you're doing machine learning, you're sifting through huge amounts of data. Machine learning and deep learning are two different categorizations, but we're just going to concentrate on machine learning for this purposes of this presentation. There are a couple of things you have to go through, the most common ones when you're trying to do something in machine learning. In this case, it is whether you're trying to identify the most important factors, which is attribute importance. You're trying to predict customer behavior, that's a classification model, or you're trying to find out if you're selling insurance to somebody, who can you sell the insurance to where you make the maximum amount of gains. That again is classification. Then there's regression, where you're trying to apply numerical quantities. When am I trying to buy the stock? When should I buy a house in this area? These are regression type of problems. And then you segment the population in clustering. Like I'm trying to sell ice cream, which category of the population should I sell blue currant to? These are all clustering kind of problems. And then you try to find fraudulent or rare events. CPU utilization of this machine is above 90%. Is this a problem or not? Network utilization is a couple of gigabits. Is this normal or not? Is this going to flood my network or not? And then the last one is you try to determine what are the co-occurring items in a basket, which is basically you're trying to find associations. Your shopping cart is a good example of this. You buy something, it says you might want to buy something else that is related to what people buy. So these are association-based problems. Some of these things fall into the category of supervised learning, and some of these fall into the category of unsupervised learning. Unsupervised learning is where the machine learning algorithms themselves have the capability to scan data and find all these interesting patterns. And then they can say, oh, this one I learned from, and these are the new kind of trends which you probably did not notice, but you want to probably build something on this. Supervised learning is the model is already trained, or it is semi-supervised machine learning, where a human is responsible for training the model. And then the model keeps learning more and more from whatever that has been specified as part of the model building process. One thing is, whenever you're doing any machine learning exercise, there's a couple of phases. There's understanding the business. You want to understand the use case. Then you understand your data. You basically want to do data visualization, data analysis. You want to profile your data. You want to find out, whether how do you build your stats? Do you group them by a certain value, or whether they're univariate or bivariate statistics? So this is the data profiling aspect of it. Then you go into data preparation. For data preparation, you want to do automated transformations, you want to do binning, you want to figure out if you want to normalize your information. Some of this is machine learning, some of this is not machine learning. So most of us who have been doing ETL, about 80% of the stuff kind of falls within the ETL space. But the cool thing is this auto data preparation and binning and some of these other methods are things that the utility currently has, where it can actually pull out some of these trends and tell you that these fields are important, these fields are not important. So it allows you to do automated feature selection. So that's also a part of the data preparation exercise. When you're modeling something, again, you do feature selections, you decide what model you want, you decide what the algorithms are, you decide what the hyperparameter settings for those algorithms are. So that's all modeling. Now, once you go into evaluation, you figure out which model is good. What are the particular values that you're selecting for the outcome of this model? Are you looking at F1 scores? Are you looking at mean square? Are you looking at root mean square? You're looking at whichever value that represents the most important things for you. Like some of the projects we've been building, they require good recall. Some of them require good precision. Some of them require good MSE scores. So depending on the use case that you're trying to look for, the model selection and the model comparison and evaluation methods change. Once you finish this, you have to deploy this. You embed this into an application. You write a report in Apex. You write a Zeppelin notebook, stuff in something in a Zeppelin notebook. You deploy this using in-database ML or using REST as part of the database, so you can expose this so that the user will have no ideas that you're actually using machine learning under the covers. So this is the part of the deployment cycle. But this is kind of like a standard methodology that most people will use when you're embarking on any machine learning project. We'll go into this in a little bit more details in a bit. So first thing I want to mention is Oracle's got this thing called Oracle Machine Learning. It was called Oracle Data Mining over the last couple of years when, I have a friend who's a statistician, and she basically came and told me once that you computer science guys are really good at this stuff because you always take these really boring terms like statistics, statistical algorithms, and suddenly call it machine learning and suddenly become super hot. So she's been working on stats for like 10 to 20 years, and she's like, it was never this hot. But now all of a sudden, everybody wants to run into AI and machine learning because all of a sudden we've made this thing hot. So this was always an option that was available since Oracle 9i, and it was called Oracle Data Mining. Of course, now the number of algorithms, number of interfaces, and number of applications that can run on top of these interfaces has significantly ballooned as compared to when this option existed in its infancy. So what this basically allows you to do is it's an in-database option. It allows you to build AI applications as well as analytical dashboards using either Apex or notebooks or Oracle Data Miner, which is basically an Oracle SQL developer extension, as well as you can build cognitive image and text-based services using this. The cool part about this is a couple of months ago, this thing was free. So if you're not used this, you don't have to pay anything for it. If you have an on-prem database, you can use this at no extra cost. And if you're using the autonomous database, all of this stuff also comes bundled up as part of the autonomous database offering. So you can actually call these as part of your Apex applications by just writing all these SQLs. So let's continue on this database developer to data scientist journey, right? So there's 6 different steps here on how to go into doing this. The first one is business understanding. You want to understand what your use case is. We went into this in a high level. We'll go into this in much more details now. So the first one is understanding the business, right? So you want to understand what is a well-defined business statement. This is the most trivial aspect of the entire process. At least I see the way people treat it. But this is actually the most important, because if this goes wrong, then more than 85% of the machine learning projects that I have worked on and I have seen that people have embarked on have failed in some form or the other because the business use case was not well defined. You really need to define what your use case is. And more than 70 to 80% of the use cases do not require any kind of machine learning. They can just be written as standard BI reports. So this is another aspect of complicating an application and trying to make it way more complicated than what it actually needs to be. And people tend to do that. And most people are like, just because machine learning is cool, you need to use machine learning in every aspect. And that's not true. That's not good, because simple simple query-based indexing and other methods like this are more than adequate to satisfy most queries. Where you need to apply some kind of a predictive analytics and where you need to go into machine learning are very, very specific cases. So you have to be very careful, and this is actually the most important step, where you need to understand what your business requirement is, and do you really need to use machine learning for most of this stuff or not. So I'm trying to predict employee turnover. So that's one use case. I'm trying to predict my customers that are churning. Like, do I have to give discounts to the customers to constantly keep coming back? Or who's the customer that constantly comes back, does not wait for discounts, pays full price, and still consistently comes back? Those are the customers I want. And then the customers that come back when I constantly give them a discount are some of the customers I long-term don't want. So I have to predict customer churn. If I stop giving discounts, how many of these customers will stop coming? How many of customers have spent more than $500+ in the most 18 recent months? So there's this thing, it's called the RFM analysis, or the recency frequency monetary analysis. There's a function that you can call as part of the Oracle data mining set of algorithms that allows you to calculate RFM analysis based on a period of time on some data, and it will automatically tell you which of these customers are the customers that are spent, not just the spending more money, but in terms of which ones are more likely to stick around and give you the most amount of gains. How can you sell more coffee? How can you sell more drinks? Which customers are likely to spend more? Who are my best customers? Which means rules and stuff like that. And how do I combat fraud? These are examples of use cases. The fraud is a very important example, right? So you basically roll up to physicians, claimants, employees, and stuff like that. So how do you combat fraud? So here's one example I'm taking for the purposes of this entire thing, is to target customers who have good credit and you basically who are going to make payments. So when I want to basically give something, I want to pick customers. I want customers that are good credit. I know these customers will stick around. I know these customers are not going to default. So I not have involuntary churn. So here's a very good example of how do I target these customers. So what are my various steps for this? First of all, the most important thing to do is credit scores. So I go into credit scores and I'm just trying to query the credit scores and seeing what information do I have. Once I have this information, I have to actually see if this makes any sense. Is age positive? Are the incomes values, are they weekly or monthly? And these values are kind of, they're not wrong. Are the loan amounts reasonable? I mean, sometimes you have a loan amount that's really high and I know this person is never going to be able to pay back these numbers. So these are data cleansing exercises, or trying to ensure that everything is on the same level. Incomes are on the same unit. It's not weekly versus monthly. Age is correct. Somebody has not inputted any wrong data. So you have to figure out all of these aspects. Then there's a lot of other stuff you can do where you can see, I want to see customers that have spent data by the maximum amount of credit cards. I want to bin them and group this based on how many number of open accounts they have. I want to find out based on loan amount as well as on income, if I want to group and find out across these customers. So there's all sorts of different views I can create as part of this notebook. So once I create these different exploratory graphs, I can understand which view of the data that I actually need. Now, sometimes this is more than enough for understanding the problem and trying to saying, okay, I've got what I want and I just need to go. Sometimes this is just the initial exploration that is going to come to eventually to decide what attributes to use for the machine learning model. Again, there are different views. Now, the previous one was the notebook view. This one is the data miner view, where you can see the same thing. You can see the binning, you can see the distribution, and you can see that there's a histogram here that is automatically generated as part of the application that shows you a distribution or trend in line before you've even done anything with the data. So all this stuff is actually built into the application itself. All this comes to feature engineering or generating attributes. Generating attributes, or in this case, is generating attributes that make sense for the kind of machine learning cases that you want to build. Like, I don't care about date of birth, I care about age. I don't care about the address, but I care about the commute time. I don't care about how many calls they placed and stuff like that. I care about the number of dropped calls and what percentage of them were international. I want to know versus the peers how much more money this person makes. I want to find out how much this person spends for food and clothing. So I don't care about the individual charges. I care about the charges binned by food and clothing. So there's a whole bunch of additional attributes. And we've known this as part of the Oracle database world, right? We build virtual columns which are derived from a combination of existing physical columns, and we rely on the virtual columns to perform certain decisions. This is something like virtual columns, except these columns will not just be used for querying, they will be used as inputs or attributes as part of a machine learning model that we are going to build on top of this. So this is feature engineering. In the Oracle Data Miner UI. So I've got different examples through the course of my presentation. Some of them in the Data Miner UI, some of them are in the Zeppelin notebooks, but you can basically do the same functions in both. They're just different. They just look different. So whichever way people are comfortable with. I like the notebooks, but I know some people who really like the Data Miner UI, and they try to play with this. So things you can do here. We spoke about this auto data preparation. The auto data preparation is basically try to find missing values, something that requires aggregation, something requires binning, some data is unstructured. All of this information can be automatically determined using built-in heuristics. So when you say determine inputs automatically using heuristics, it will go through and say that this one is, what type of mining type is this? Is this categorical? Can it be automatically tuned? Is this something that is used in most models, or this kind of field is changed into some other kind of field and then used in the models? So like age can always automatically be binned instead of using date of birth. So that system does automatically for you, because it knows that age it's a much better value to play with as compared to date of birth. So this is the auto data preparation aspect of it, where you go through all the features and you decide which features you want to use. Now there's another method for this. Is once you've visually inspected the features, you've gone through the data, what these features represent, you go into something called attribute importance. Now when you're doing attribute importance, it's a method to invoke, where you pass a whole bunch of data and say, based on this input data, tell me which one is more important. Like if I'm trying to sell insurance, should I look at a person's bank account, or should I look at the number of claims they've made? These are the examples of where I would use attribute importance as part of the mining function. And then it would automatically group it and give me the columns that are more important relative to each other. And then I pick those columns as part of the key attributes. Now you see, this is a lot of work just to come up with the interesting attributes of what I need to do. So, but this is very, very important, because if I pick this thing wrongly, then my model is going to go completely haywire. So just a quick recap of the steps. I decide what I want to do. I want to find the customers that have the best amount of credit so I can sell stuff to them. I want to find out what are the attributes. I use auto data preparation to eliminate some of the columns. Then I use attribute importance to decide among the columns that I have now, which ones are the most important and which ones can be fed into a model. Now remember this, the biggest problem with feature engineering is if you feed too many inputs to a model in terms of attributes, then the model takes way more time to train as compared to what it would be when you give a smaller number of features to the model. It's just like, if I have a SQL query with 500 columns versus 50 columns, it just makes it a lot more complicated to query and to figure out which columns are interesting, which columns are not interesting. So the more data you give to your model to train, the longer your training exercise is going to take, the more these attributes are going to influence the process of training, as a result of which the output of this model could be complete garbage. So the goal of this entire exercise is to find the smallest number of features that will make the most amount of impact, and that's going to be used to train your model. That's all that this entire process so far that we have done is trying to do. It sounds complicated. Once you do this a couple of times, then you know this thing is really, really fast to accomplish once you do this iteratively a couple of times. So once you know you've picked the attributes, right? The next step is basically training these models. Now, most of the default models we have use 60-40 random samples. There's this thing, it's called cross-fold validation. A cross-fold validation is a process where you take, say, an example. I'll take some data, divided this into 10 pieces, right? And then what I do is I take one piece, I pull it out, and I swap that between the training and the testing sets, and I run it against the remaining 9. And then I keep doing this in a rolling window fashion. So I take the next set, I take the next set, I take the next set. So I keep switching testing and training with this. Now, this is a process in this case, because it's 10 pieces I've divided this training set into. It's called 10-fold cross-validation model. So by doing this, what you're doing is you're moving a portion of the training model and using that iteratively as testing by removing it as part of the model. And you're trying to improve the chances of trying to find a good test train model split. Again, this process is called n-fold cross-validation. And in this case, by default, we're using 60-40 random sample splits for doing this. So once you split, you can also apply n-fold cross-validation on top of this entire process. Once you build these models, there are 4 aspects that change. 1, the testing and training data, the combinations of them. So as you can say, there's more testing, there's less training, there's more training, there's less testing. And then you take a chunk of the training model, you put in the testing, you take a chunk of the testing, you put it back in the training. You keep swapping data back and forth. So the test and train model splits is one of the variables to change. The second one is the attributes. You can decide which attributes to pick. You can decide the attributes based on attribute importance, based on different kinds of feature engineering. The third aspect is you can change your algorithms. You can decide you want to use decision trees. You want to make use of any of the deep learning models with LSTM. So you can switch on the algorithms. The fourth aspect is you can change the hyperparameters. When you change the hyperparameters, so hyperparameters to an algorithm in a model are init.aura parameters to a database. That's the relationship. So when you change the hyperparameters, it changes the way the model actually performs its task. Like if you're doing, most of the algorithms have an n random value for performing its operations. If you're using random forest, then you can change the number of forests as you go, the k values. So there's clustering. You can change for k means. You can change the k values. So there's all these different hyperparameter attributes that you can change as part of the machine learning model. So these are the 4 things: the test train data, the hyperparameter optimization, the algorithms themselves, and the attributes. And you have to basically do a permutation of all of these continuously to come up with which of these models gives you the best score. Now, earlier, this used to be a manual process. Earlier, when I'm talking about, meaning about a couple of years ago, slowly, there have been more and more AutoML systems that have been basically taking on this task. And AutoML is a different topic. We will cover this as we go further in the presentation. But this entire process is automated today and can be run as part of a framework where you can basically run and say, give me the model with the best score for this. And it will automatically do all of this stuff for you. Once you do this, you randomly hold out samples. You mentioned, I told you, right, we're doing random sampling where we hold out a certain percentage of the training data and we use it as part of testing, the cross-fold validation process. Once you do that, you calculate the outcomes, which are the gains, the lift, the accuracy. And once you use these things, you can decide which particular attributes to change, which model makes sense. So the model evaluation exercise is to compare the outcomes of all of these different algorithms and try to see which ones of these make sense. If I'm looking at lift, I'm looking at accuracy, I'm looking at gains, I'm computing cumulative F1 scores. I have to decide based on what metric I'm going to use to come up with these algorithms. And then you deploy this. So when you deploy this, the SQL statement is just going to call, in this case, I'm using prediction probability with the N1 class model, which is basically a classification model, to automatically determine what the credit score bin is going to be. Now, this might require some training. There's also, when you build the model, like in this case, I'm building a model called claims model. I'm using something called support vector machines, which is one of the model types. I'm using auto preparation for this exercise. And automatically, when you apply the model, and then you can just run the queries, it'll tell you which are the policies and which are the percentage of fraud that's most likely to happen in most of these policies based on the previous claims that these people have done. So you see, it's not that complicated. It sounds complicated, but it's not that complicated once you do this iteratively a couple of times. Very simple SQL functions. And all of these algorithms are basically built inside the database. So if you're already doing ETL exercises, you already have facts and dimensions, and you're running queries and joins against these things. This is just one extra layer where you basically have to decide which algorithm to use, what amount of which attributes to pick, and then you run this training. And then once you fit the model, you can run the queries and just get their outcomes all inside the Oracle database without actually having to move away from this. So these are typical steps for a data scientist. Now let's move to more examples, right? So here's an example for I'm trying to find the average purchase amounts for men versus women, and they're grouped by income level. So I'm using this thing called t-test. Now, so when you do stats t-test in-depth, these are the functions you can use. You can basically find p-values, the two-sided p-values as they're called. Now, this p-values less than 0.05 shows statistically significant differences in the amount purchased by men versus women for those particular category types. Now, here's an example of a simple statistics-based SQL query that will basically give you this answer. This is example number one. Another one, I want to attribute importance. Remember, we spoke about attribute importance a lot when it comes to feature engineering. In this case, I specify the attribute importance. I specify the tables and the columns, and then which is the target column type I want to influence. And then I also specify the settings for the attribute importance, which are also. So the way this works in this is that you have to create a separate table for the settings, and you have to insert the values, the hyperparameters for those settings inside this table. In this case, it's ADT import mode settings. And then you can query the attribute name, rank, value. And when you do all of this, it tells me that the most important thing is to find out if the person has enough money in the bank and if they have overdrawn any money monthly. So these are the two things that you want to look at before trying to, go for that person for your insurance. So this is attribute importance. Same thing for if you want to build this in R. So OML has different implementations. The current implementation in production is OML SQL, which is basically you can write all your machine learning code in SQL. Now we're coming up. Now there's OML for R and there's OML for Python. It's called OML for Pi. These are two of the distributions that are coming. OML for Python is my favorite because a lot of machine learning languages or machine learning platforms like scikit-learn, which is what I learned most of my stuff from, are basically written in Python. So Python is a very, very flexible language. Some people love SQL. They can stick to OML for SQL. But if you're a Python guy, people are like, I have fewer choices. How do I operate against the Oracle database without pulling data out of the Oracle database, right? So one thing you see is a lot of people, what they do is they extract data out of a database. They make it into a CSV file. They load this into a pandas data frame, and they run their queries against it. Once they've built a model, they push it back to disk. And then they import the results back into a database, and they run the query reports on the database. So there's all this back and forth. Now, when the data is just running into a couple of gigabytes, it's okay. But when you're running into several terabytes of data, this is the same problem we used to have when you're working with Hadoop installations, where people take huge amounts of data from Hadoop, they move something from Oracle, and they move it back to Hadoop, data duplication, as well as data movement, and you're creating huge amounts of work when you're moving data across two platforms. So one thing we kind of came to a conclusion of is we need to support Python natively as part of the database stack. We need to support R natively as part of the database stack so that people no longer move data back and forth between this because it's not efficient. It takes a lot of time. So the goal is to move the algorithms to the data and not the other way around, not to move the data to the algorithms and try to do something and then move the data back into where it originally was. Here's an example of doing this for the OML for Pi. This is coming. This will be supported within the autonomous database platform. It will also be available as a standalone download that you can actually run on your machine against a 19C or 20C database with the data mining option built into it. And all they're doing is you're creating the AI model and you're fitting the AI model using the train X and train Y, which is basically the training and the training model in this case. The X and Y again represent the labels. The Y represent the labels, the X represents the input attributes. Again, it shows you the importance and the same exact exercise with the Python. Now, the autonomous database has obviously had this for some time. We have this OML package. A lot of people have seen their notebooks. I'm not going to go through this too much because there's been enough presentations on this. I know my colleague Heli has spoken about this, and Edelweiss has spoken about this. They've spoken enough about the various features of what are available for all of this. I'll concentrate on the things that are coming. And this is interesting because this significantly changes the game for us. So first of all, a lot of people, like I'd mentioned, move data back and forth from the database, and they try to take the data to their servers. They make CSVs, they play with stuff, and they move it back. So the first thing we decided to do was build a transparency layer. Now, what is a transparency layer? Imagine a data frame that basically connects itself to the backend as a table, and you can manipulate and do all sorts of stuff to it without even realizing you're actually connecting to a table and without writing a single line of SQL. So anything you do in Python or R, you can manipulate a data frame object. You can take the output of this data frame object and make a scikit-learn library operate on it. So think of it as a join between some stuff I'm doing in scikit-learn, some stuff I'm doing using OML, and I'm combining their results together to basically get my output. So you can combine things between two different languages, two different sets of libraries, and use proxy objects so the data continues to stay in the database. So it looks and behaves like a pandas data frame, but it's basically something like a DB link, to make it simplistic. It's like a DB link into a database at the backend, and someone who does not know SQL can completely write all these things in Python. It basically overrides all the native functions and translates the underlying functionality to SQL. So if you're a guy who doesn't like SQL and is a person who's familiar to working with R and Python, and there are many of us who are like that, this is great to manipulate database data without actually having to get into the database at all. There's the thing that we spent the last couple of years working on is basically trying to make some of these algorithms more parallel, more distributed. Now, there's a lot of the stuff lying in open source, and some of these open source algorithms might be way more cutting edge and ahead of the stuff that might be inside the database. But the thing that we have in the database is basically tried and tested, stabilized. We know this stuff really works, and we adding every subsequent version that comes out, the algorithms that we know that absolutely work. We expose these as part of using OML for SQL. So like we added stuff for time series. I'll talk about a few new algorithms we added as part of 19 and 20C. But what we do is the algorithms that we know for sure, they work. They're not experimental. Someone's not trying to write a paper on them. These work, and they're production deployable, and they're reliable enough for you to build your models on. And we know that these models really work and its outcome really works. We add those algorithms to the database itself. So some of these algorithms, they can be run in parallel. Now, everybody knows about extproc. extproc allows you to run all sorts of things. So most of the stuff for OML for Py and OML for R are basically run using extproc as external processes that connect to the database and do something and return results back to us. So there's a client that connects to the database, runs queries against it, and then the database server itself can spawn off more helpers to do something outside and then punch the results back into the DB, all while keeping the data consistently inside the DB. And that's the parallel distributed algorithm aspect of it. And then we are obviously focusing towards AutoML because we don't want people to do feature selection, model selection, hyperparameter tuning. There's a whole bunch of existing clients that are already there for people who want to use R. There's RStudio. If you want to use notebooks, there's Oracle Machine Learning. People who love SQL Developer it has an Oracle Data Miner option. So there's stuff for everybody, and it's applicable across a swathe of languages. AutoML is most interesting. I already spoken about most of the content on this slide. The thing that's most interesting is it automatically reduces the number of features by identifying things that are most predictive to improve the accuracy of the algorithms. So basically, it does not require you to be an expert. It's going to automatically figure out which things are interesting for you. Now, the good thing that's coming is there's going to be a new OML, AutoML interface. Now, what this is going to do is it's going to automatically bin data. It's going to show you importance as part of this data. It's going to have a model leaderboard. It's going to show you which models are good, which models are known to perform better as compared to the other models. And you can deploy all these models using REST. You can track a model if the performance of the model is degrading as part of this. It's like you push out a new model for a Facebook feed, and suddenly you realize that the engagement drops. You can immediately go back and revert back to the previous model for your Facebook feed. The same thing here is like you release a report and people are using this report for doing something, and suddenly people stop using the report because the report doesn't work. So you need constant model monitoring where someone will continuously iterate through this model and try to find something better than what's already out there. or if the model regresses once it's actually released into production. Like it works for day one, and then suddenly people realize that this model really does not work, and then people stop using it. So that's model monitoring. So this will allow data scientists to take this to the next level where they don't have to run all these things. It will automatically calculate the histograms. It will automatically calculate the importance. It'll run the various combinations of algorithms and calculate a score. And then you get all of the various values that are necessary for you to make a decision as to which ones you want to use, as well as it will have a model leaderboard, and then we'll do monitoring. So this is coming. It'll allow you to do a whole swathe of functions. Like here's an example with SVM Gaussian 1, what sort of deployment it is, and what do you want to basically predict. So there's a whole bunch of new features that are coming as part of this. The two new algorithms I mentioned earlier that we added, in this case for 20C. Now XGBoost is present in almost everything, and it's like it's one of the Gaussian methods that is very, very popular, and that's used for classification, regression, ranking, and survival. So one of the things we wanted people to do is we wanted them to be comfortable with the same algorithms that are basically available across all of the open source packages out there. We wanted these things to be present inside the database. So these two basically gave us the biggest bang for the buck. So there are a couple of other things for time series also that we're working, but these two are the ones that are worth mentioning at the moment, which is gradient boosted trees or XGBoost. And then the other one is basically MSET, SPRT, which is multivariate state estimation techniques and sequential probability test ratios. Now, these are the second one is an anomaly detection algorithm to monitor processes. And what we do is we use this as part of some of our AI ops exercises to look for some kind of an anomaly from the signals that we are trying to basically monitor. This there's Oracle. We have a group called Oracle Labs where people build some of these algorithms. They speed them up inside the database. They try to re-implement them in different ways so it can easily be consumed as part of the database itself. So this MSET SPRT method is one method for anomaly detection that we use pretty heavily internally within the company, and it's something that you can use as well. And XGBoost, everybody knows what gradient boosted trees are. It's an extremely popular method for performing classification regression. There are tons of Kaggle competitions as part of this stuff. I mentioned there's the Oracle Data Miner UI. I'm not going to spend too much time. There's all these various templates that are available as part of the autonomous database. So the bottom line is you can basically manage and analyze your data. If you have the big data appliance, you can do all sorts of stuff with it, with Hadoop, with Hive, with Kafka. So the conclusion sort of is you don't need to move your data. I think that's kind of the number one conclusion you can take, is moving your data around is inefficient. If you can run most of the machine learning in the database, it basically saves you huge amounts of time to try and do this. You can set up data preparation and transformation using automatic data prep going forward. This thing will save copious amounts of time in terms of preparing the, now remember, all this is after you already have the data, you've already cleansed it, you've already loaded them, they've already done you've built up your partitioning data scheme, you've built facts and dimensions, you know how you're going to query all this stuff. After this, you want to build the models on top of this. You want to use automatic data prep to decide which of the attributes you're going to build. It doesn't matter what language you know, SQL, R, Python, you can, whether you're like writing stuff in notebooks, you like writing stuff in the UI, in Data Miner, it doesn't matter which method you like to do. There are so many different ways to get to this. And the most important thing is you do not require the machine learning skills, because AutoML significantly speeds up the entire model building exercise. So as long as you're concentrated on your business goal of getting good results, you really don't need to know how these algorithms are implemented, where they're implemented, how good these algorithms are relative to each other, because these things keep changing. So here's an interesting stat, right? So my team works on all of these different kinds of exercises for AI ops. Sometimes we spend 3 to 4 months working on something, and then we figure out a new algorithm or model that basically obsoletes all that 3 to 4 months worth of work. It's very, very common for us to basically hit these kind of scenarios. So one thing we realized is we don't want to concentrate on the model building exercise. We don't want to concentrate on the hyperparameter optimization exercise. That's what AutoML is for. We only want to concentrate on the outcome of this model, and does it satisfy what we want to do. So it significantly lowers the barrier to entry for the average person who has no ideas of what machine learning is, but understands their data really well and knows what the outcome they want from this data. And then there's obviously, you don't need a second instance for production to transform any data. All the data is embedded. All the transformation is embedded. And once you have, you want to do model scoring, we've accelerated model scoring as part of Exadata. And this thing can be done repeatedly as many times as you want. You see this chart. Now people ask, like, why do you guys talk about all of this? So for people that are data scientists and kind of like do this on a daily basis, they want to know if their favorite algorithms are supported. They want to know what are the various kinds of functions that are available. They want to know what language packages do they have, whether we do things with like time series, right? Like we use Holt Winters pretty heavily using time series. So I want to know if Holt Winters support is present or not. I like lasso for regression, for based on the things that I do. For attribute importance, I like PCA. So you want to know if the methods that you are commonly using as a data scientist are available or not. So this goes from the standard 3 bins of machine learning for classification, clustering, and regression to going to anomaly detection, to going to time series, going to attribute importance, and then going to text mining. If you want to build something using explicit semantic analysis for document similarity. So we use a combination of ESA and TF-IDF internally for scanning all the logs that we get from the database, from Exadata, and all of that sort of stuff. So this thing gives you a perspective of the vast swath of algorithms that this thing supports, and that you know if you go for this, it's going to have not just the algorithms for machine learning, but also a whole bunch of statistical functions. You know, the ones we most commonly use are median, standard deviation, you know, min, max, lag lead functions for SQL. These are very common because most of us know these. Ranking functions and cross tabulations are also pretty common. But, you know, ANOVA, linear regression, t-test, f-test, these are not very commonly used by DBAs, and some people don't know what this is, but we have support for these. So it's like one of the examples I had provided earlier was, you know, the ones where you're trying to determine, you know, for men versus women, you know, based on the income levels, who spends more for what items. And that was an example for t-test. So there are lots of more examples. As you see those examples, you realize when you can actually apply some of these statistical functions, and they're just a simple function call as part of SQL. So there's no learning curve for you as a DBA or developer. If you want to make use of some of these functions, you see a couple of examples. It's like learning from Stack Overflow. And once you figure this out, you know that the database has the support for all of this. To conclude, ML and AI are just algorithms. You don't need to learn any of this stuff. You can use what's already there, but you have to move the algorithms to where the data is. And that will significantly save you a huge amount of time when it comes to doing all of that stuff. Thank you. And that's what I had. Questions? I'm going to stop sharing and probably go to chat if I have any questions here.
Thank you, Sandesh. I think the guys didn't.
I think I bamboozled the audience. There are no questions.
Yes. There is any questions on YouTube? No, there is no questions.
So by the way, I just want to mention this, that, you know, this is a lot of content to take in. If you got even 10% of this, consider it good, because, you know, most of us spend months trying to learn some of this stuff. The cool thing about this entire field is it's sort of like democratizing. You don't really need to know the details of how this stuff works in order to try to figure things out.
Okay, we have one question now. Does OML support unstructured data?
Yes, yes. So all those algorithms, half of them operate on top of unstructured data.
Thank you.
Any other questions, guys?
I think people are too shy, or you clarified all questions.
I think the best way to get your hands dirty on this, so like I said, if you have like a database 19C available, you can install data miner, or you can you know, get a notebook fired up and work against this, or if you're just too lazy to do any of this stuff, just create a free autonomous database account, create a machine learning user, and you can just log into that and start using all the existing notebooks that are already there. There's tons of sample notebooks for you to get started. It should not take you more than 15 minutes to start writing your own pieces of machine learning code. So lots of examples, lots of templates that are already there. All you need to know is SQL. At the moment, OML for SQL is the only thing that's there inside the autonomous database. But OML for Pi and OML for R will be shortly available for doing this. I think OML for Pi is a game changer. Sorry, go ahead, please.
No, it's okay. Sorry. We have one more from Andre. What do you think for the next movement of autonomous database? What we can expect from autonomous features?
I think it's a platform. There's more and more applications that are going to come around this platform. So I remember this when we started off. The autonomous database was intended to automate a whole bunch of stuff, but the key that I always felt was the support of applications that are going to be around it, right? So how do you load your data? How do you query your data? How do you have support for Apex for building reports on top of your data? How do you you need a whole bunch of other things that will allow you to utilize the platform. So it's the power is in the applications, not in the platform. The platform is just a platform. It's like electricity, right? You turn on a switch and you don't care about the power plant and your transmission wires and all of this other stuff that comes to it. But it's the device that connects to the electricity that it's like right now it's like super hot. Where's the air conditioning, right? But I don't think about the electricity that's powering the air conditioning. So machine learning, Apex, the ability to basically do OML for Pi, where Python developers can gain access to this. It's a vibrant apps ecosystem. And I think we started developing that over the last year or two, and I think that's going to significantly accelerate. So more and more developers can basically use the platform. If they don't care about the platform, it doesn't matter. They can just use the platform, and the application ecosystem around the platform will continue to develop. So from SQL developer to SQL developer modeler to Apex to OML for Pi to OML for R, AutoML, all of these are just going to accelerate the applications ecosystem around the autonomous database. And I think that's the thing that gives me the kick for it. It's like people come and tell me, oh, I added this feature for autonomous. Now we do this thing a little faster and stuff like that. That doesn't excite me as much as like when I see, oh, you've added XGBoost support. Finally, it's like, what took you guys so long? Because I've been using XGBoost as part of scikit-learn, TensorFlow, and all of these open source packages for some time. And I need the same features inside the database to make it at par and say, hey, look, why can't I use my favorite algorithms in the database for doing most of this stuff? So that is changing. So today, if I have to write something, say, for example, I was using scikit-learn for something, I will move a couple of terabytes of data, and then I move this somewhere, I do something with it, and I move the data back. I have to always keep doing this back and forth, and this, after a while, just gets really annoying. And now I just write a simple bunch of SQL statements. I don't have to move data anywhere, and it basically does the exact same thing. So it's, after a while, when you start using it, it's incredibly powerful. Notebooks and notebook servers are very popular.
We have two more questions. One, can I access the ML2 from the Always Free account?
Yes.
And okay, yeah, just a continuation, the same model. And another one is how can a DBA migrate to this area to play with machine learning? What is the easy path, or what kind of recommendation you can give?
So there's like I said, the first thing to do is just go into OML. I don't know if I have it here. Give me 1 second.
Just share your screen again, because I think you're stuck.
Yeah, give me something's happened. This thing has just crashed. Hang on, I'm gonna post a link in chat. Just give me 1 second. Yeah, I'm just gonna post this thing in chat.
Okay.
So this basically shows you how to get started with the OML notebooks.
Nice.
If you're a DBA, you don't know what to do, start here. So you need to have a free autonomous database account. When you create an autonomous database, you go into Service Console, and in Service Console, you create an OML user. Once you log in as that OML user, you can do everything that I've suggested. You can fire up notebooks, you can write. So right now it's OML for SQL. You can only write code in SQL. At some point in the future, the near future, you'll be able to write things in Python and R directly into the notebooks. So all of this will operate on top of data that already sits inside a database. And a data frame will basically be a representation of the table that is there underlying. And it will look very familiar to you. So you can actually use it with scikit-learn libraries or any of the other libraries that you want. So,
Very nice.
And yes, this is all part of the Autonomous Database free OML package.
Perfect.
So also I remember I mentioned to you, if you download like 19C, all this is part of the DB. It's part of the data mining package, and it's all free. So all of this machine learning stuff that I spoke about is free, whether you're using it in an autonomous database or whether you're using it on-prem. Of course, you have to set up your own notebook servers. You have to deploy these functions using REST, and you have to expose them to your notebook servers. If you're doing them manually, if you're using the autonomous database, someone has already set up a bunch of notebook servers for you, and there's less work for you to do. But if you use this on-prem, you write these functions, you can expose them via REST, and you can build a notebook server and just connect. You can use the stuff from Jupyter, and you can connect it directly to these REST calls coming from the database.
Very nice, Anesh. Any more question? No,
like I said, even if you learn 10% from what I've said, it's great. That's the idea. Get slowly started, start playing with things. The only way you're going to learn is more and more. The more you play with this stuff, the more you learn with it. Otherwise, it's just get this thing out of your head, okay? Machine learning is not complicated. Just like how, I remember when I used to teach stuff for RAC, people are like, ooh, RAC, multiple instances, all this stuff. This is all complicated. It's not complicated. You don't need to know the algorithms. You don't need to know statistics. You don't need to be a math major. You don't need to know any of this stuff. Don't listen to what people tell you, okay? As long as you know what your problem is, what you're trying to solve, all of these are just tools. This is no different than the tools that come up with, say, 20C new features for database, and there's a whole bunch of new features for you to learn as a DBA or a developer. Machine learning is just one more tool in that Swiss Army knife of tools that you have. And you can use this without actually knowing any of these algorithms or how they work or, how they build and stuff like that.
And that's from me. When you realize that you want to play with machine learning, in what moment in your career you start to looking at it?
Lots of people learn this because they think they want to be cool, want to show the fact that they're learning machine learning, and you kind of know something that some other people don't know. I have been in the debugging space for pretty much the last 15 years of my career. I spent time working troubleshooting Exadata environments, and then I realized that there's a lot of stuff that we do on a daily basis that basically can be automated. We start writing scripts, like what we used to do like 10 years ago, continuously writing stuff. Today we've automated using Ansible, Chef, Puppet, and all of these other frameworks, Runbooks, Runas, and all of these other things that are currently available. And then I realized automation is just one aspect of it, but there's a lot of problems that can be solved by simple machine learning, where I'm looking for workloads, I'm trying to determine an adaptive baseline. All of these things can be simple machine learning examples for how to do this. So I got into machine learning to solve my own problems, to solve my own pet peeves, because I didn't want to keep doing the same thing. Laziness invents most stuff. I'm an extremely lazy guy. So if I do something like 5 times, I have to spend more time to try to figure out how to automate it, because I don't want to do it again. It's boring. So the more I started working on this stuff, the more I realized that we're spending too much time doing this. We're spending too much time doing this. We've done this 50 times in the last 1 week. Why the hell can't we automate this? And it's that pet peeve for me that I started working on using machine learning. So for me, it was not what everybody else does. Oh, I want to learn machine learning because I want to look cool. I want to, survive in my career. I want to.
It happened naturally.
It just happened naturally because I had a problem that I wanted to solve. I'm not a mathematics major. I'm not a statistical person. I would not grade myself as an ML expert either, but I'm a learner. So I look at problems, I look at tools, I see which tools apply to my problems, I learn those things, and I move on with that. So that's why I keep encouraging people. Do not think you have to be an expert in something to be really, really good at it. You just start playing with things, and you slowly, you just grow into it. If you enjoy it, you just grow into it. So machine learning is one such aspect of it.
We also receive a hello from Gianni Cereza. It's following on YouTube, and also Rodrigo Jorge.
Awesome.
Thank you, man.
Thanks a lot, guys.
Awesome.
Thank you. Enjoy the rest of the day, guys. A lot of interesting sessions coming after this.
Yeah. Now we will have the session of Robert Mars. Thank you for the attendees to come to join us today, and thank you for watching. So, Robert, can you share your screen right now? Okay.
Hi, can you hear me?
Yes, perfect.
Perfect. So, welcome everyone. Good afternoon. Today I'm going to talk about Oracle Cloud Infrastructure, and we are looking at the network part of the cloud infrastructure. I hope you're all ready, or shall we wait another 2 minutes for bio breaks, and or shall we start right away? Just go ahead and start.
Yeah, you can start right now.
Okay, here we go. So again, hello everyone. My name is Robert Marz. I'm an independent consultant, so freelance, from Frankfurt in Germany. By the way, can you see my video?
Yes.
Okay, perfect. Frankfurt is the city right behind me, and as freelance architect, as freelance consultant, I'm usually acting in the role as a senior technical architect with a very database-centric view of the world. So all those Java architects out there are my personal friends. I'm an active member of LuxOUG, which is the German Oracle user group, and here I'm responsible for the cloud topics inside the database community. And I'm tweeting from time to time, and this is my Twitter handle below here. This is my Twitter handle, and this is my website. And if you have any questions about anything I'm talking today, just drop me an email at robert@datab.org, and I will do my very best to answer it. I am an Oracle ACE, and the Oracle ACE program isn't a closed club, so you can become one too if you wish, or probably you know someone who deserves to be an ACE, so please download the slides after the presentation and click on one of these links at the bottom, and you can just see if you can become an ACE or someone else you know. Okay, so what are we going to do today? Why networking for DBAs at all? Well, if you start your brand new cloud account, it is a little bit like you start a brand new virtual empty data center. So you have, with every cloud account you open, you have a new data center attached to your on-premises environment, and it is an empty data center when you start. And before you can bring in all these computers in the cloud, it will be virtual machines mostly. You have to do basic setups and wirings, and these are the network setup. And this is very important, and this is the reason we are going to talk about that today. The next question as a DBA that I asked myself is, do I have to do this all by myself? No, definitely not. Sorry. No, definitely not. Ask someone who knows this stuff by heart, and there's probably some guy in your organization that is in charge for these topics. Please don't forget to ask those guys. But do I really need to know this stuff? Nope, you don't need to, but the Oracle Cloud Infrastructure is network driven, and that means everything depends on the network. This is, by the way, true for every cloud provider or every infrastructure as a service cloud provider. And on the other hand, it's the topic of the session, so knowledge never hurts. Let's dig into it and see what networking is all about. So if I know the stuff after the session, what is it good for? Well, you can help yourself. Much more than on premises, you can configure stuff in the cloud by yourself, mainly because after Open to Freshly account, the rights aren't restricted so much. So you usually have way more rights than you have in your on-premises data center. You can just walk in and plug and unplug cables in the cloud, but not in your on-premises data center. A good idea of what you can, or where you can help yourself is if you ever needed to configure DNS entries for scan listeners, so multiple IP addresses for the same DNS entry. For example, if you want to set up Oracle Real Application Cluster, all this kind of stuff, then you can do it by yourself in the cloud without explaining this complicated task to the network staff. Okay, so what are clouds made of nowadays? Well, Linux servers, mostly. And besides these Linux servers, there are lots of other supporting stuff inside the cloud, and mainly network components. Luckily for what's happening here, I'm pressing the wrong button, sorry for that. Luckily for us, most of the thing is virtual, at least the stuff we can configure and we are faced with as cloud users. And this is defined, software-defined networking, software-defined whatever. So the SDX means it is virtual and we can configure it via software. Okay, so before we dig into the network stuff, let's have a little look at the basics of the Oracle Cloud infrastructure. I took this picture from a German marketing slide, and there are a couple of German words on it, but I think we will make it over together. So on the foundation of the Oracle Cloud is the Oracle region. An Oracle region, to give you an example, is Frankfurt in Europe, Frankfurt, or Amsterdam, or Zurich, or the big US region in Ashburn, or Toronto, or whatever. And those regions consist of data centers. And these data centers are called in Oracle terms availability domains. And they are abbreviated by AD typically. The aim of Oracle is to have at least 3 availability domains in every region, since the Oracle Cloud infrastructure is expanding very fast at this time. They didn't achieve that in every region. As far as I know, in the Swiss Zurich region, there's only 1 data center available, and there are a couple of more which have only 2 data centers. But the aim is to have at least 3 availability domains in every Oracle region. The data centers are equipped with very fast physical network and all this computer stuff, and even they are interconnected. All data centers inside the region are interconnected via a very fast physical network as well. Above this physical network layer, here comes the virtual network, and this is the first layer that we can access. And as you can see at the how the slide is structured, or how the picture is structured, the virtual network is really the basement and the foundation of what we can change and what we can configure. So the virtual network is really important. Building on the virtual network came all the services that the cloud has to offer: compute, storage, database, autonomous database, networking itself, of course, with all its higher networking services, and all this kind of stuff. And building on top of that comes the governance. So your departments, your applications, whatever. And we can, of course, connect on the right side to other Oracle regions, to other cloud providers, or to your on-premises data center. The Oracle Cloud is evolving very fast and is developed very fast by several teams that are distributed all over the world, and that led to a little, some kind of confusions, especially in course of terms. There are a lot of terms that are different, but meaning the same thing. One important term is identity domain, tenant, and cloud account. Although they sound very different, they mean all the same thing. Whenever someone is talking about an identity domain, a tenant, or a cloud account, it means your cloud space. The name of your cloud space is part of your cloud URLs, and you need to the cloud account together with your password and login into your database. Just to show you an example on how confusing it can be, you see here a screenshot of the login mask that I get presented when I'm trying to log on through the Frankfurt Data Center directory. It says assign in to your cloud tenant. And if I use a different approach, so a different URL, which leads to the same result, there is a fly around me here, which leads to the same result, I get a different masks that talks about a cloud account, and there says cloud account with identity cloud service. So different terms, same result, same meaning. Just keep that in mind. Another term we have to talk about, because they are very important, are compartments. Compartments are logical dividers inside your cloud account. So you can use them to group cloud resources together. I personally think of them like namespaces or subdomains. You use them to separate your departments or your cloud applications, and the cloud resources used to stay in their compartment. So only recently, a couple of months ago, Oracle introduced a new feature that allowed you to switch some cloud resources between compartments. The month before, you needed to delete and recreate them if you wanted to move a source virtual machine or whatever from one compartment to another. That wasn't a big problem because those are only logical dividers. All resources can always see each other, even if they are in different compartments. Taking the compartments for an example, you can see how fast the Oracle Cloud is evolving and new features are developed. I have an example here. I compiled these 1.5 years ago, and there was a very new feature introduced at October 18th, 2018, that made compartments deletable. And only a year before, they made it renameable. And so if you started with the Oracle Cloud Infrastructure and created a compartment and made a typo before September 7, 2017, you need to live with this typo and with this wrong spelled compartment for virtually your whole life. So you weren't even able to delete it or to rename it. And those features are introduced very fast and very fast pace. And even recently, they introduced a new feature that allows movement of resources from one compartment to the other. Good. Now, let's start talking about virtual cloud network. In Oracle Cloud Infrastructure, you use the Virtual Cloud Network wizard to create cloud networks. And whenever I hear something talking about a wizard, pictures like this little lady come in my mind. And or the other way, an old white man with a hat on it or something like that. But believe me, reality in terms of Oracle computer wizards look very different. So the Oracle Cloud Network Wizard is launched via the burger menu. We will see this in a second. I will give you a short demo of that. And you choose the networking virtual cloud networks, create virtual cloud networks. So very intuitive. You can create resources in one easy step. When you start the VCN wizard, you can choose between if you want to start a virtual cloud network with internet connectivity or with internet connectivity and a side-to-side VPN connect. So there are more steps added to the second wizard. Again, this is a very new wizard. They completely reworked the wizard. A couple of months ago, you had the option between create a virtual network or a virtual network with additional resources. And these additional resources would be created, but you had to accept the predefined IP range. You couldn't even change the IP range. Talking about the IP ranges, all created resources by the wizard can be modified after the creation. With one big exception, this is the IP range. So we have, if you want to change the IP range of our virtual network, we have to recreate the network as a whole. It's not possible to change it at this time. Okay, so time for a demo. Let's have a look at it and let's see if it works. This is my web browser here. I just went to Oracle.com Cloud Sign-In and my cloud account name, my tenant or my identity is Robbie Databee. I just choose, this is my username and password. So let's go to it. And my primary region is Europe Frankfurt. So I come to console Europe Frankfurt 1, you see in the URL. And this is the startup screen that you get presented after logging in. So we can even, they added a couple of quick actions. So we have the networking wizard right here, but let's click away this COVID-19 message here. So we can start the wizard from right here, but the way I showed you on the slides is press the burger menu and the upper left buttons, go to networking, go to virtual cloud networks. And so this is the list of my virtual cloud networks that are in my root compartment. I don't have any there. Let's see if I have some in my, these are my subcompartments. So I have a DOAG, German Oracle User Group compartment, the database community and the development community. And let's see what's here. Oh yeah, and this was for my try run. So let's just terminate that here. I did a try run just before the real presentation, so, and it didn't clean up after all, but this works very well. So here is it gone. Let's see if we have one here as well. Delete it, terminate is the correct term, and throw away. And off we go. So let's start with the database compartment, and let's say, so now the choices are create virtual cloud network. You can configure everything by hand or use the wizard. Let's see what happens if we say we want just create a network. Let's give it a name. Let's stick with the name I chose in the try run. Lux Oracle User Group 0. Let's take plain. We want to create it in the compartment. Every resource you create has to be placed in a compartment. So we want to choose the compartment DOAG database. The CIDR block is the network block. So let's just type something. Let's say we start with 10 and then 168 and then 10.24/24. We can have a DNS label, which will be LuxOUG plain, and a DNS domain. Here we go. Advanced options are not that much. You can add tags. If you're using the cloud a little bit more intense, you will be happy for every option that to group resources together, because resources tend to multiply, and you will have lots and lots and lots of different resources in your account. And so tag is one way to group them and to do reports over them and find them. But we don't want to add a tag at this time. Just create the VCN. And as you can see, this works very fast, and we have created a VCN. Together with the VCN, we got a route table, we got a security list with our firewall rules, and that's it. Okay, so let's see what happens. We are going to the development department. The developers are a little more lazy than the database guys, and they want to use the wizard and create more stuff in a single step. And this is the new wizard I talked about. We have the choice between virtual cloud network with internet connectivity or with internet connectivity and VPN configured in one single step. So the VPN part would be too long for the demo, so let's just create an internet connectivity. Here we are. Let's call it LuxOUG and wizard. Wizard, yeah. Wizard. It is in the compartment DOAG-dev. Let's configure the subnets. So again, this is a new feature. A couple of months ago, you couldn't change the IP blocks, but we can change them now. So let's see, we want to go here to 160, and let's take the 70 block, and we have to put the subnets inside the big CIDR block. So this will be 161, or let's say, and 15. I'm just making up numbers here. And 160 and 25. Yes, we want to have the DNS resolution. Again, we can show tagging options here. Let's go to the next step. We get a summary here, and we together with our virtual network and the two subnets, we get a couple of gateways, an internet gateway, a NAT gateway, and we will see what these are about in a couple of minutes. We get security lists, routing tables, and all this kind of stuff, and say, okay, go ahead and create. And as you can see, this works very fast. And now we have created a virtual network. And we have a virtual network. We have a public subnet, which is reachable from the outside, from the internet. We have a private subnet. And that's all I want to show you for right now. Okay. So let's continue. So by the way, these are my demo backup slides. These are the screenshots from the old wizard. I will update those screenshots before downloading the slides tomorrow. So when you download the slides, you will get the demo screenshots from the actual user interface. Okay, let's talk about the networking stuff. If you want to configure network components in the Oracle Cloud, we have a couple of terms we stumble over. The first is, of course, VCN. VCN is short for Virtual Cloud Network. And in the Oracle Cloud, it is IPv4 only. So we have no IPv6. That isn't much difference to the other clouds. Most of the other clouds I know are running on IPv4 only as well. It's just for you to know. In the Oracle Cloud, VCN covers a single contiguous CIDR block, so a single contiguous IP range. Other than other clouds, you can have, if you want to have multiple IP ranges, you need to set up a virtual cloud network for every range. That's not a big problem, just a thing you need to know and to consider when planning your networks. Cloud resources cannot be placed into virtual networks directory or your virtual network cards you create, but they have to be placed in subnets. So every VCN needs subnets, and you can choose between a regional scope, so a subnet that works over all data center in a region, or you can assign it to a specific availability domain, so to a specific data center in your region. This is a new feature as well. A couple of months ago, you needed to set up a subnet for every region and do the route. The routing was handled by Oracle by default, but you needed to set up a subnet for every region. So if you want to create a virtual network interface, the VNICs here, they have to be assigned in a subnet, and every VNIC in the same subnet share the same routing table, the same security list, and the same DHCP options. Okay, so I told you that Oracle networking in the Oracle Cloud is IPv4 only, and there are public and private IP addresses. The public IP addresses are unique, and when I say unique, I mean worldwide unique. So you probably heard that those public IP addresses are limited, and that we are at the end of the available space for public IPv4 addresses. Nevertheless, the cloud providers, all cloud providers did acquire companies over the couple of last years with the only goal to acquire those IPv4 ranges, and Oracle did so, and all other cloud providers did so as well. And they have lots of IP addresses available, so that's not probably a problem. Nevertheless, there is this problem, the networking guys are aware of the problem that these IP addresses are limited, and so they standardized on private IP addresses. Those private IP addresses are predefined ranges that are used over and over again. And since those addresses are private, packets with an address in a private network won't be routed to the internet because no internet router knows which is the real destination. Okay, so these are the private IP networks. We are not going over the details, just for you to know that there are 3 different blocks. There is a 16-bit block, which has 65,000 addresses, and the range is going from 192 to 168. You probably get assigned one of those addresses from your DSL router at home. Then there is a 20-bit block starting that has over 1 million addresses divided into 16 small networks, and these addresses started with 172. And there is a big 24-bit block with 60 million addresses in a single network, ranging from 10, the 10 network at least. So all IP addresses starting with 10 are never routed to the internet. And if you remember what I just entered inside the wizard when we created the virtual network in my cloud account, this address started with a 10 as well. So just for you to consider, the lower block here is often used in home cases or in small offices. These ones are used mixed, and these are typically used, the address block that are used in big organizations for their virtual network setups, or for their physical network setups as well. So IP addresses in the same subnet are considered local. That means no routing is required. Local means your network card assumes that it can reach the address of the destination from a packet if it's local directly by sending your package directly to the next network card. This is calculated by subnet masking. And subnet masking is a very simple binary AND operation. You can do this by hand by yourself, or if you're lazy as I am, just Google for network calculator or IP subnet calculator. And there are lots of good websites outside where you fill in the information you have and get calculated the missing parts. Nevertheless, let's have a look on how this works. IPv4 addresses are 4 bytes divided by a dot usually. So every one of you should have seen an address like this here. So we have an address 192, 168.132.197. And for the network interface card, it looks at the binary representation. Each byte has 8 bits. So the decimal range will be from 0 to 255. So there will be no number greater than 255 in an IPv4 address. And this is the binary representation of this IP address here. The subnet masks, every one of us should have seen something like that. This is 252, 252, 252, 0 in this case. And the binary representation of this mask is lots of ones and a couple of zeros at the end. And if you do a logical AND operation, we get the network address. So so if you do the logical AND operation in this case, we get this address 192 blah blah .0, and every address, every IP address that results in the same network address. So if you do the binary AND operation with the network mask to the address, every address that has the same network address will be considered as local as in the same subnet. This is how you type this. If you're a Windows user, you probably have typed, or a Linux user as well, you probably have typed in one or other case something like that. My network, this is my network address mask, or net mask if you're on Linux, with the net mask with the 255.255.0 at the end. This is a lot of characters to type, so some guys considered of a shorter notation. And this is the CIDR notation. The CIDR notation is just the IP address, or a single IP address from the network. Usually you use the lowest one, the network address, but you can use any other, and a slash, and a number. And the number calculates very simply. You just have to count the ones in the network mask. So If we have a look at the binary representation of the network mask here in the third line, in the fourth line of this table here, we will see that there are 3 bytes of all ones. So 3 times 8 is 24. Though our CIDR location is /24. And it's that simple. That's so is the CIDR address calculated. And one may ask, what happens if there is a 0 before the first, there is a 1 after the first 0. So imagine there is a single 0 here. What would the CIDR number looks like? Well, it's very easy to answer that. This will be an error. This is a not allowed subnet. This is not allowed subnet mask, and your IP stack will throw you an error and not accept that mask. Okay. So let's have a look at a couple of examples here. In that case, let's say, okay, I have an IP address. I intentionally didn't choose the lowest number from the network here, just to show you that it's possible. So we have that IP address here with a network mask of 28. This is the decimal representation of this network mask, and let's just show what happens. So let's take this IP address, the IP address from the network notation, by the way, and apply the mask, and this will be the result. We have a 192 at the end. Let's have a look at the next IP address. If we take the 190 and apply the mask, we will see that we get a different masked IP. So this IP is not in the same subnet, and there has to be routing. There has to occur some routing that you can reach this IP address from that IP address. Next address is the same thing. We use the 209, we will get a different network mask. And if we use the 200 at the end, that will be in the same subnet than the first address, and those, the first line and the last line will see will be in the same subnet and can reach without routing each other. Okay, these are a couple of more examples of subnets. I'm not going to read them out. Just if you want to read the table by yourself, I just have entered here the lowest IP address, lowest usable IP address, and the network address. The network address isn't usable as an IP address because it's the address of the network. And the same as with the highest IP address. The highest usable IP address from this network is one lower than the highest address than the highest possible address from this range. And the highest number is called the broadcast address. Every package that is addressed or that has a destination with the broadcast address will be distributed or read by all network cards on the subnet. So if you do a ping on your network, this will usually use the broadcast address, and every not a ping. If you an ARP request, if you do an ARP request, that will use the broadcast address, and you will receive answers from every network card on the on your subnet. So, why is planning ahead is important in terms of IP routing? IP routing occurs whenever a packet has to leave its subnet to reach its destination. So you can easily think about that if you say the network is, the destination IP address is not in the same switch, so not directly cabled together. Addresses on the own subnet are considered local. These are the ones where no routing occurs. And this is the reason why you should never overlap IP ranges in networks. You can do this, but then you are in deep trouble to keep these stuff together. You can do this, you can overlap IP ranges, and you can use subnetting and nutting and all this kind of stuff, but you probably don't want to do this if there is a chance to avoid it. So please plan ahead, use only new IP ranges for your networks, make them as small as possible and as big as necessary. Remember, a couple of months ago, you had to have at least a single subnet for every availability domain. So your subnet should be your network range should be big enough to fit 3 times of all possible IP addresses or of the number of machines that you want to reach inside your network. This is not longer necessary, so you can make those IP ranges even smaller, but make them big enough that you have space to move around. Think about as your cloud account as a new data center. So this is a chance for a fresh start. So you can avoid all the mistakes and errors you made when you set up your last data center on premises. Ask the guys who did those mistakes, do proper planning. And there will be a lot of quick and dirty trials. So if you're playing around with your cloud account, just spinning up a couple of virtual machines, setting up a couple of networks like I did with just entering some random IP address ranges, don't let those become productive. It is very easy in the cloud to destroy and to tear down installations and setting them up again. Do this. And do this in a proper way so that you don't get a headache afterwards. Okay, let's continue having a look on those network interface cards, on those network terms or components that are in the Oracle Cloud Infrastructure. One of the most important things is probably the VNIC, the Virtual Network Interface Card. Every virtual machine needs one. There are a lot of more resources that need network interface cards. Every VNIC has at least one private IP address. So one IP address from a private network. The first private IP assigned to a VNIC is the primary IP of this network interface card, and it will be unchanged during lifetime. So you can't change the IP address, the first assigned IP address to a virtual network card. If you want to change it, you have to destroy or to tear down the network interface card and rebuild it. It's not a big deal, but you have to be aware of that. Public IP addresses are routable from the internet. You can optionally assign them to those virtual network interface. A single virtual network interface can have multiple private IP addresses as well if you need that. And public IP addresses are free of charge in the Oracle Cloud. This is a difference to other cloud providers. The 50 static IP addresses are free available for playing with. If you need more, you have to open a service request and you will get probably assigned more free of charge, or you have to talk to your sales representative. If you want to set up a public IP address, you need a public subnet, so a subnet that is declared public, and an internet gateway. And if you remember the wizard I just clicked through in the first demo, we got created a public subnet and an internet gateway for that purpose. We have routing tables inside our network. So you define routes from one subnet to outside the VCN. The default routing table is empty. So there is a routing table there that will be that is created with your network, but it is empty. We have security lists. Security lists are firewall rules. So every cloud has a firewall available up and running, and those firewall rules need to be defined if you want to have traffic between your virtual machine. There are two kinds of firewall rules: stateful and stateless. Stateful means that the firewall keeps track of your IP packets, and if you send out an IP packet to somewhere, and a response comes back from a direct response to this packet comes back, the firewall will let it pass. This means stateful. Stateless means you have to define rules for both ways. The stateless thing was important back in the days when memory in routers were very expensive and tend to get full with or filled up with those stateful rules, and then you needed to define that. Nowadays, you usually go with stateful and you're happy. The rules are named ingress and egress. Ingress means inbound and egress means outbound. The reason why they aren't called inbound and outbound is they not only apply for inbound and outbound traffic, but for traffic inside your network as well. So if you have set up a subnet and have fired up two virtual machines with two different virtual network interface cards, these two machines can't reach each other with packets directly, only for the rules that are allowed. So firewall rules are firewall rules will affect the traffic inside your subnet as well. This is this is, by the way, default for every cloud provider, and this is one of the reasons why clouds are very secure and there are not that much breaches and incidents happens in public clouds, because you really have to allow every network path. And this is a great difference to your on-premises network, where the inter-subnet traffic is allowed by default by your switch. The default set that is generated when you generate that is in place when you generate a new virtual cloud network consists of ingress rules that allows SSH. So SSH traffic is always allowed, and two types of ICMP traffic. ICMP are those ping responses, and the type 3 and 4 are packet fragmented and some error message. We will see this in a second. And the other rule is that any traffic in the outbound direction, the egress direction, is allowed. So the inbound direction, the ingress direction is very limited, and the outbound is allowed by default. There are DHCP options. DHCP is a protocol that allows you to configure IP addresses for virtual network end cards or to assign IP addresses automatically. This DHCP standard has lots and lots of options. There are over 100 of things you can automatically assign to network interface cards, from DNS servers over time servers to all kinds of stuff. The Oracle Cloud has very limited options to be precise, the DNS type and the search domain. And that's all you can configure for the standard DHCP options. If you want to have more, you have to set up your own DHCP server. Okay, so let's click around. We have a couple of minutes, so let's see. What I wanted to show you are the security list and the DHCP options. So this is my wizard, my network created by the wizards. Let's have a look at our, and we got created 2 subnets, 2 routing tables, one for every subnet, the security list and the DHCP options. Let's just have a look at the security list. And this is the security list for the private subnet. Let's have a look at that. And you can see we have 3 ingress rules, so the inbound rules. This one allows the destination part of the traffic to TCP 22, and 22 is the TCP traffic for SSH remote login. By the way, these comments are generated automatically, and this is very helpful. So if you set up your own rules, you will get, if those are known ports, you will get up those comments generated by default. The next rule is, and this SSH is for our subnet only, and for our virtual cloud network only. This is the range of the cloud network here. And the next are those ICMP package 3 and 4 for the world 000 here. And here is ICMP 4 destination unreachable, fragmentation and needed, and don't fragment was sent. Those the one is 3 and the other is 4. And 3 is destination unreachable. And this one is the third rule defined only for our subnet. If we have a look at the egress rule, there's only one, and that allows all destination, all protocols. And so the egress way, the outbound way is allowed by default. Okay, that's it for those options. We wanted to look at the DHCP options. Just go there. DHCP options here. These are generated here, and if we have a look at those, we can just click on those 3 dots here and say edit. You can see, okay, we have default DHCP options, and we can say, okay, we want our DNS type as internet and VCN resolver or a custom resolver and the search domain. And this was generated by the wizard. Okay, so back to the slides. We still have a couple of minutes. So those are the demos. And again, before I I make the slides available. I will update those to the latest version, to the screenshots. And let's have a look at the gateways. Gateways that are generated, there are several types of gateways. And because it's easy to define different gateways for different purposes, Oracle did so. So the only thing you need to know is that depending on the task you want to achieve, you want to set up a gateway as a router, a virtual router. Depending on the task, you need to choose the right router, and then everything will work out fine at the end. So if you want to do dynamic routing, this is meant for VCN and on-premises connections or private network traffic connections, use a dynamic routing gateway. If you want to go to the internet, use an internet gateway, and so on and so on. Those are the two peering options here. And the service gateway is used for other services in the Oracle Cloud that are outside your virtual cloud network, for example, object storage or your backup stuff and all this kind. Okay, how do we get to the cloud? We have different paths into the cloud. One is the SSH tunnel. This is the thing we always get set up in the demos that are provided by, say, be it Oracle, be it Azure, be it Amazon. And so you just SSH to a public IP address of your virtual machine and open and do port forwarding so that the ports from the traffic to the ports on your local machine are just tunneled to the cloud. This works well, but only for testing and development. You don't want to have SSH tunnel for production setup. The next thing is a custom firewall appliance. And this is the method of choice in the Azure cloud and the, as far as I know, in the Amazon cloud as well. So you just spin up your own compute instance, your virtual machine, provided with a custom image where your firewall appliance is there, and do your setup as you wish. And if you assign it a public IP address, you can do your can set up your VPNs as you need it and as you want to have them. The preferred way by Oracle or is IPsec VPN. You do that by a dynamic routing gateway, and this will set up an IPsec networking between your on-premises or and your on-premises network and the cloud network, or between two cloud networks. And the final option is the OCI Fast Connect. Fast Connect means you have your own private connection. You have a real or virtual private line, a cable that gets plugged into a switch that is inside the data center. This peering can be private or public as you wish, and it sounds expensive, and it is expensive, but not in terms of the cost of the cloud, more in terms of costs for the leased line that you have to have, because you need the leased line from your data center to the cloud data center, and you need a dedicated leased line inside the data center to the so-called meet me room where you plug in those cables. Okay, so this is how IP tunnels work. You just open a port on your local host, do an SSH connection to a jump server over here, and forward those packages to your destination host. This is very straightforward. I took this screenshot from MobiXterm. This is my preferred terminal environment for Windows. This illustrates how this works. If you want to connect to an autonomous database in the cloud, we have a little problem because those can't have virtual network interfaces. So the access is encrypted via internet. What you need to do is you download a wallet. This is a zip archive containing a couple of certificates. And you, if you want to use SQL Developer, you can just import it directly to SQL Developer, or you have to unzip and configure it for SQLnet. And then you can connect to your autonomous database. Let's talk a little bit about costs. I prepared this slide for a couple of currencies. The dollar currency is the most stable because there is no currency conversion in. So let's have a look at the dollar slides here. So this is, I took this screenshot here on the left side from the Cloud Oracle.com networking pricing website, and I did the screenshot from today. The good news is I had another screenshots from 2 years ago or 2.5 years ago, and the prices were the same. So the prices didn't change. And if you see the first 10 terabytes per month are free, and the inbound data is totally free, and the outbound data from perspective of the cloud is built after the first 10 after the first 10 terabytes. And sorry, let's go back. And the gigabyte price is less than a cent per gigabyte. And this is close to the Oracle won't make any money out of networking, because those costs are very close to the charges Oracle is getting charged for the big internet connection nodes like DE6 here in Germany, or Me East and Me West in the US. So the maximum cost, if you have a 1 gigabit connection to your cloud, and you have it up 1 month and fully loaded over 1 month. Let's just calculate that. Let's think we have 30 days in a month, 24 hours. So this and it will roughly take 3 hours for a terabyte. I know you can, if you really use the full gigabit line, you can make it in 2 hours and 40 minutes, something like that. But just for easy calculation sake, let's say we need 3 hours per terabyte. So that means we can transfer 240 terabyte per month if we use our gigabit line to the full. And the first 10 terabytes are free, so let's remove that. So we have 330,000 gigabytes that we have to pay for, calculated by the price, and we will get less than $2,000 per month. And and this is the maximum price you have to pay per month for the network, and that means you need to set up a really big cloud infrastructure environment with lots and lots of servers that are all sending out data to the internet, and this really rarely happens. So you can keep in mind the networking is the cheapest part in the Oracle Cloud. Let's have a look at the Fast Connect cloud pricing. Fast Connect is astonishingly cheap. So if you want your own 1 gigabit per second line, you only have to pay 21 cents per hour, which is a little bit funny because usually you don't send a technician once a day to plug in your cable. So typically you have to pay this for the whole month. So again, let's calculate that here. We have 24 hours per day, 31 days. So we have 744 hours in a month. And the price for the 1 gigabit per second lane will be $158. If you want to have 10 gigabits, you only have to pay $900. So this sounds very cheap, but you have to keep in mind that you have additional costs. So you need a network provider. So you have to have a leased line, a dedicated line to your, from your data center to the cloud data center. This is probably the biggest part of the cost. And inside the data center, you have to lease a line as well. I put that in bracket because I don't know what is true. Some Oracle officials told me that you don't have to pay any OCI outbound traffic if you're using fast connecting, and this is what's stated here. On the other hand, if you have a look at the cost calculator, the cost estimator, and I did that today, it calculates the cost of the gigabytes as well. So I'm not sure what really happens, what Oracle is really charging us, since I don't have a leased line or fast connect available. So there are two options. One is you don't have to pay those $2,000 here. The other is you have to pay it. I don't know. On the other hand, the good thing is I didn't make much of a miscalculation here. So even the cost calculator says that the 1 gigabit line cost us $158. I don't know where the difference came from of the $1.10 to my calculation, and $949 for the 10 gigabit line. Good. Final topic before we come to the end, scripting. Scripting means automation, and this is the bare definition of infrastructure as a code. So building up and tearing down virtual environments happens very frequently in the cloud. So you will find yourself, if you start working with the cloud environment, you will find yourself rebuilding virtual machines and stuff over and over again. And this is mainly because some changes can be only made by recreating the resource, for example, changing the IP range of a virtual network. And the provisioning of the cloud resources by clicking in the user interface is very tedious and error prone. You will find yourself abbreviating and leaving out comments at latest at the third time you recreate the same resource. And you are doing typos and all this kind of stuff. So my advice is use the web interface for orientation only, just to see what is possible, what you can do, and what the correct terms are used for the things you want to do. And then script everything. Scripting is automation and documentation at the same time. So if you script your setup of your network or your virtual environment with virtual machines, you have it automated and you have documented at the same time. And this is really the bare definition of software-defined infrastructure. So the scripting options we have is the REST API. This is the master. It provides you access to all resources and options inside the cloud. What is not available via the REST API isn't there as a feature. On the other hand, scripting is using the REST API is more programming than scripting because you need to do all this kind of state checking and error checking and all this kind of stuff. There is an OCI CLI. This is the command line interface to the cloud, and I have an own talk about that. And that is Python-based. It's available for Unix and Windows and for macOS as well. It is open source, hosted on GitHub, installs very easy. The installer will even install Python if you don't have it on your Windows machine. And it is also, it is open source. It is developed by Oracle and maintained by Oracle. So it will cover all the features. The de facto standard of scripting the cloud is HashiCorp Terraform. HashiCorp claims to have scripting across all major infrastructure as a service providers. So the idea is that you have to write a script only once, and you can fire it against multiple providers. This only works, of course, if you don't use any specific features that are available only for a specific cloud provider. The provider for Oracle is open source as well and developed by Oracle. So Oracle makes sure that all the features are there. And finally, you can choose your configuration management tool of choice. I picked as an example Ansible, but there are Chef and Puppet and all these other kinds of tools as well. And again, there are OCI modules provided by Oracle here. Okay, so finally, networking in the cloud is basically the same as networking on premises. So your cloud account is like a new data center. Use your chance, plan ahead. And the web interface is only the second best thing. Script everything. Please do so. And if you do so, not the sky, but the cloud is the limit. This little line should be over the sky here. And please, please, please do try this at home. Networking is cost-free in the cloud. So go ahead, use it at home. And thank you for your attention. I'm done. Any questions?
Thank you, Robert. We have one question here.
Okay.
How do you get to the network utilization report?
A network utilization report? Actually, I don't know.
Maybe on financial.
I never had the requirement, but we can have a look at the cloud interface if we find something like that. I would have a look at again in the burger menu. At the bottom, there is account management, and you can go to the cost and usage report. I would search it here. And since I don't have much going on in my cloud account here, since it's full payment account with any free option, without any free options, I would find it here. I think or we will find it. I have no idea. To be honest, we have to ask Oracle how to do that. I have no idea.
Okay, maybe set up some alert or something like that.
Yeah, probably.
Okay, thank you so much for your wonderful presentation.
It was a pleasure.
Yeah, so we need to move to the next lecture. It's about time right now. Thank you so much, and thank you for all attendees to join us today. So now we will have the presentation from Alex Zabala, also about the cloud. Let me unmute Zabala. Okay. Hello.
Hello, can you hear me?
Yes, perfect. Just share your screen to mute my microphone afterwards.
Mhm.
Perfect.
Just a minute. Okay, can you see my slides?
Yes, we are seeing your screen.
Okay, let's start. So I will stop my video because otherwise you only pay attention to my pretty face. So the slide is much useful. Let's start to talk about how to move your on-premises database to the Oracle Cloud. The good thing from this presentation, it's not only to move to the Oracle Cloud. You can use these concepts to move to any other cloud, or if you are planning to move from one server on premises to another server on premises. My name is Alex Zabala. I'm an ACE director from Brazil. And yes, I'm doing a lot of Oracle certifications on my free time. I'm based in Dallas since June 2019. It's 1 year now. I start my career in Brazil as a developer in 1997. Start my Oracle career in 2000 as an Oracle developer, forms, reports, and designer, SQL, PL SQL. 2007, I moved to Angola as an Oracle DBA for the Ministry of Finance. I spent there 8 years. 2015, I moved back to Brazil and started to work for Enkitech. And I was there for 4 years. In 2019, I moved to Dallas, and I'm still working for Enkitech. Enkitech is now part of Accenture. The Oracle is program. If you are interested in the program, you can talk to me or any other guy from the user group. So let's start talk about how to move your database to the cloud. So the Oracle idea for the cloud, it's very nice because you can use the same architecture, the same software, and the same skills you are using on premises, you can use in the Oracle Cloud. So everything you do on premises, you can do in the Oracle Cloud. A warning about autonomous database, because I'm seeing a lot of people making some confusion about it. So database 18C, 19C, or 20C are not autonomous database. So autonomous database, it's a cloud service. You can have autonomous database if you go to this cloud service. If you download on premises, this database, it's not autonomous. Another question, a lot of people are asking the same question with the Oracle Cloud or the autonomous database. Will I lose my job? This is my opinion, no, but you need to learn new skills. For example, application. You need to start to help your developers on design and development. You need to learn architecture, and especially in the Oracle Cloud, you need to learn the infrastructure, network security, and infrastructure as a code. So you need to update your skills to stay relevant when you are a cloud DBA. Some tools that I recommend you to start learning to automate and your deployment or tasks, especially in the cloud. So I recommend you, if you are going to Oracle Cloud, learn OCI, CLI, learn Terraform, and learn Ansible. Oracle Database Cloud. So some services you can use in the Database Cloud. You can use Database Cloud services, virtual machines, or bare metal. You can also use the Exadata Cloud services. There are two types of Exadata services. You can use the cloud services, or you can use the cloud at customer. This is exactly the same services, but this machine will be deployed on your data center. And you have the autonomous database for OLTP and for DW. So first thing you need when you are thinking to move your database to the Oracle Cloud, it's determining your shape to move to the Oracle Cloud. You have some options. First option, I am the DBA, I know everything. You can use, for example, the same amount of CPUs and memory that I have on premises. It works, but probably you are losing and burning your money because the servers and the cloud are brand new servers and powerful. Probably more CPUs are more powerful than you have on premises. So the best way to check your shape you need in the Oracle Cloud, it's using this database consolidation workbench. It's part of the Oracle Enterprise Manager. The only problem here, you need to have the diagnostic pack because this tool will analyze your AWR based on your retention. Another way is using this MiG360. I will explain later this tool. So I created this tool to help people to migrate the database to the Oracle Cloud. So you have a lot of options to determine your shape in the Oracle Cloud. So you can use a lot of tools, or you can try to guess. And when you have this answer, based on the definition of number of CPU, memory, and storage, you can create your database in the Oracle Cloud. So in this presentation, I'm assuming you already have the database created in the Oracle Cloud because it's pretty straightforward. It's like 3-4 clicks. You have your database deployed in the Oracle Cloud. When you start to thinking about move your database to the Oracle Cloud, you have this link here, oracle.com, go to move. You can select your source and you can select your destination services. And This web page will provide you the documentation about all the options you have based on your source and your destination. Some migration methods you can use. You can use, for example, data pump, or you can use recovery manager. You can also use like SQL developer, and the new PDB architecture. You can use things like remote cloning or unplug and plug. I will show later on my tool, the MiG360, all the options you have, and I will provide some examples. So don't worry if I'm going faster on the slides, because I prefer to show everything in my tool. If you are migrating from non-CDB to CDB, I recommend you to read this blog post from Mike about all the pitfalls you can find when you are migrating your database from non-CDB to CDB. So spend some time reading this and check everything you can happen during your migration. To choose your migration method, basically the most important, it's on-premises database version and cloud database version, because for example, I can go from on-premises 10G and I move into the Oracle Cloud 19C. So based on my on-premises version and the cloud database version, I will have some options. Also, your on-premises host operating system. For example, if I'm moving from AIX to or Solaris to cloud, all the service in the Oracle Cloud is Linux. So I need to use some options to convert my database to Linux. Another important point is the database size, because it will affect your options and also your network bandwidth. So how much data can I send to the Oracle Cloud? And for me, the most important, it's your downtime. So how long is your downtime? So like, can I have like 3 days or 5 minutes? If I'm moving, for example, my database 11G on premises to 11G in the Oracle Cloud, I can use these options. I can use data pump, conventional or transportable table space, or I can use recovery manager. If I'm doing some conversion here, I can use recovery manager convert. So don't worry, I will explain with examples all the options. I'm just show very quickly the options you have. If you are moving from 11G to 12C, 18C, or 19C in the Oracle Cloud, you also have this new option, full transportable. If you are moving 12C, 18C, 19C, and you are using the CDB architecture, you are moving to the Oracle Cloud, I have all these options. So I can unplug my CDB, transfer the files and plug, or I can do a remote cloning. I can use SQL developer. If I'm doing the same migration, but my on-premises is non-CDB, I have all these options. So I can use, for example, remote cloning, the non-CDB option. I just need to move, plug, run a script to convert to CDB, and all good. As I said, downtime, for me, it's the most important part of your migration strategy. So you have to discuss with your customer the downtime. Why? Because, for example, if I'm using the public internet and my database has like 100 terabytes, it can take like 8 months to move my data to the Oracle Cloud. So this is very important to understand this concept. To load data in the autonomous database, if you are moving your on-premises database to autonomous, you need to be aware you cannot use tools like Recovery Manager, or you cannot unplug and plug your PDBs, and you cannot use the transportable table space. If you are going to autonomous database, you need to use one of these options. You need to use SQL Developer or Data Pump or Golden Gate. Well, if your database is very big and you need to move faster, you have two options. You can use the data transfer services. This is basically you move your backup data to your hard drives, and then you send the hard drives to Oracle, and Oracle will import in object storage in the Oracle Cloud for you. Another option, you can request to Oracle this data transfer appliance. So you can request Oracle to send you this appliance here. You move all your backups to this guy and send back to Oracle. And Oracle will upload all this data to the Oracle Cloud. You don't need to be worried about the security of this data, because you have some security steps you need to do, and only you, even if you miss the hard drivers or the transfer appliance, only you can access your data. Another option, if your database is not too big or you have time to move to the Oracle Cloud, you can use this guy here. I will explain quickly and show a little example how to use this. So basically, you are doing your Recovery Manager backups from your on-premises database. So your backups are going directly to the Oracle Cloud to object storage, and then you can use these backups to create your database in the Oracle Cloud. First thing you need to do here, download this module. You can go to the OTN website, download this guy, and upload the installation file to on-premises database and to the cloud database. And to install, this is the installer name. It's a zip file. You have to unzip, and then you run java -jar this command to install the backup module. If you're planning to do, you can go to this link. There is step by step you can follow to install. First thing, I'm going to my database server in the Oracle Cloud to configure and install this module. So basically, this is my command line. So for example, all these parameters, you can find how to get this information on the previous link. So basically, you need your private key, you need a fingerprint, you need the ID for the user, and you need the tenancy, and this is the wallet. Here is the directory, the module you create on your server to store the wallet, and where is the location for your library files. So for example, I'm running here with all these parameters, and then this installer will create a parameter file, OPC2, and your database name here. Basically, in this parameter file, you have the object storage name. You transfer your on-premises backup sets to the Oracle Cloud, and the wallet. So this is very important because I don't need to provide my username and password every time I'm running my backups. So Oracle can go open this wallet and check your username and password. So you did in the you install this module on premises. Sorry, you install previews on the cloud, and now you do the same steps on premises. So basically the same command line, same parameters. Here it's my server on premises. So I have the same parameter file with all the information. Okay, then I can start to configure my recovery manager after install the module. Basically, I need to use, this module works like a tape library. So basically you need to configure this tape library to use your module and to use your parameter file. This parameter file, you know, there is the object storage location and wallet and everything you need. So you do this command on recovery manager to configure the destination. Okay, so I have the module, I have the recovery manager pointing to the Oracle Cloud. So now I can start and do my backups, my on-premises backup to the Oracle Cloud. One thing very important, you need to set your encryption. You need to set a password, otherwise you get an error because you are moving your on-premises data to the Oracle Cloud and you need some kind of security here. So only you can open these backups later. The options I have to backup, I can use, for example, like this, backup my database to my tape library. This tape library is pointing to the Oracle Cloud. Or, for example, if I'm planning to move my databases and I can use like this strategy, the incremental, I can do level 0 first, and I can start do the level 1 incremental backups. So I can have avoid a big downtime if I'm using this strategy. So I'm creating the level 0 to the Oracle Cloud. With this level 0, I can create a new database and I can do the incremental level 1 and apply the incremental backups in my database before open the database. When you do your backups here, you see your data files. Oracle is moving to the Oracle Cloud, and you can go to the Oracle Cloud, to your object store, to your bucket, and you can see the files here. All the files here are the backup sets from Recovery Manager. So you open. Now you can go to the database server in the Oracle Cloud. What do you need to do to create a new database in the Oracle Cloud based on your backup? First thing, start up no mount to create a dump instance here. Set your decryption. Remember, you set your password to create your backup. Now you have to set the same password here to decrypt the password. And also set your DB ID. Another thing you have to do, restore your SP file. You can point to, for example, to this location, and you restore from your backup. After restore your SP file, you can start and restore your control files. And mount your database. So you have now a database in mount stage. And then you can start to restore your database. So you can see here, recovery manager are reading the library, and the backup's located on your object storage. After he stores your database, you need to recover your database. You have some options to recover your database based on the version you are. For example, you can recover until the SCN, or until cancel, or until the available redo. And depend on the option you use to recover your database, you can use the open your database reset logs or no reset logs. So it depends your strategy you are using to recover your database. The problem with this kind of approach to use database cloud backup module is I cannot upgrade to the new version during the migration. So for example, if I'm moving my database 11.204, I need to create an 11.204 database in the Oracle Cloud, restore, recover, and do the upgrade later. If you go to this blog post, there is one script created by Oracle. You can run all these steps in just one command. So if you're planning to use the backup module to move your database, I recommend you to go to this blog post and see the script. It will make your life easier. So that's all for the cloud backup module. Let's talk about the data pump now. Using data pump. For example, I can use cross Indian. For example, if I'm moving from Solaris to Linux, I can use data pump. Or for example, if I'm moving from database 10G to 19C, I can also use the data pump. I can move from non-CDB to the CDB architecture. I can do some changes. For example, I'm moving from my on-premises database is using like file system, and I want to move to the ASM. I can use the data pump. And of course, I can upgrade to a new version. I can go from 10G to 18C, for example. How to use the data pump? One option is to go to on-premises, create your physical directory on your SO, create your directory inside the database pointing to the same location, and then I can export my entire database, or I can export just a few schemas. Same thing we used to do on premises. After export my database, I can go to the Oracle Cloud, create a directory here in the Oracle Cloud, and then I can move my export file on premises to the Oracle Cloud using SCP. Using SCP, it's one of the options. I can also move my DMP file to an object storage, and I can use the data pump import pointing to the object storage. I will show later how it works. So you move your file, and then you have to do the same. Go to your cloud database services, create your directory, and import. Options you can consider when you are using the data pump strategy. It's possible to create a database link. For example, you will have a fast connect link or a VPN between your on-premises and the Oracle Cloud. You can create a database link between the database, and you can use the network link option on the data pump. And as I said, you can move to object storage, and when you are importing your database, you can point your dump file to the file in the object storage. So you don't need to create a file and transfer file to the SO in the cloud. Another option, you can use the transportable tablespace. It's also cross-Indian possible. You can move from database on premises like 8i to a 19c database. You can move change the architecture, and of course you can upgrade to a new version, moving from like 10G to 19C, for example. How it works? Basically, it's the same with a few more steps. You have to create your directory on your server, create your directory inside the database pointing to the same. If you are using data pump transportable table spaces, you need to make your table spaces read-only before you export the data. So it can cause downtime for you. So remember this step. You need to make your table space read-only, and then you can export your metadata using this option on the export utility. Transport table spaces and the table space name. Again, go to your database in the Oracle Cloud, create the directory in the SO, transfer the files. You need to transfer your DMP files, and you need also to transfer your data files. And here you can go to your database on premises and put your table spaces back to read, write. On your cloud server, create your directory inside the database, create the user, and then you can import pointing to the new data files. And then after import, you need to put these table spaces in read-write mode. So this is the option you have when you are using the data pump. Another option is to use the data guard. This is a very good option to avoid downtime. So basically you have your database on premises and you create your standby database in the Oracle Cloud. When you have the database in sync, you can do a switch over from on premises to the Oracle Cloud. Let me explain quickly basic steps to create how it works and how to create a data guard. There are a lot of options, but I'm showing one of the simple options to create the data guard. The problem using data guard, you cannot go cross-Indian. For example, your on-premises database needs to be Linux to move to Linux. You can change the version. The good thing, you have the minimal downtime, and source version you can start from 11.204 to 19c. Two ways to do this. You can use the database as a services, or you can use the infrastructure as a services. Basically, the steps are: create your physical standby, prepare your client connections. You need to change the TNS names from your clients, and then you do a switch over when the database are in sync. You can go to this PDF if you need to know more about this option. Basically, you have your on-premises primary database production. You create a standby database in the Oracle Cloud. Your clients are going here. When you do a switch over, your clients go to this database. First thing, your database on premises need to be in archive log mode. So if you are running databases in production, I really recommend you to have database in archive log mode. And this is a very important step to have your database in force login. It will avoid you some headaches when you are doing the migrations to using the data guard. You need to create your standby redo logs on premises database and of course in the cloud. It will depend on the number and the size of redo logs you have on premises. And the recommendation is create one additional group. For example, if you have 3 redo logs in production, create 4 standby logs. To create the database in the Oracle Cloud, you just need a parameter file with the database name. Create your ADUMP file. Create your password file. You can create a new one, or you can move your password file on premises to this server in the Oracle Cloud. Export this variable pointing to the same DB name. Open the SQL Plus. Start no mount pointing to the parameter file you created with only one. And then connect to Recovery Manager. So this is your production database. Auxiliary is your standby database in this example. And then you can duplicate your target database for standby. You can use, for example, from active database if you don't have the new backups on premises. And then you have a database created and ready in the Oracle Cloud. The next step is to create and prepare your client connections. You need to change your TNS names, open the firewall port, and do all the network configurations. To do a switch over, it's not an obligation to use the broker, but I like to use the broker because it makes your life easier. So basically you need to enable the broker, connect to the broker, create your configuration pointing to your primary database, and add your standby database, enable configuration, and when everything is ready, you just do a switch over to the standby. Another option is to use the Golden Gate Cloud Services. This option is very good to avoid downtime. So you have your database on premises replicating to the Oracle Cloud. So it's another option if you like the Golden Gate, if you have Golden Gate knowledge, you can go and use. It's a very good option. Using Golden Gate, you can do basically everything. You can go cross-Indian. You can move from 8i to 19c, for example. You can migrating from CDB to PDB. You can change the database structure. Good thing, minimal downtime, and you can do the upgrade to a new version. So using Data Guard, you cannot, but using Golden Gate, you have all these things you can use. There are a lot of options. I will show you now using the migration 360 script. Let me open here. So you can go to the GitHub, to this guy here. Basically, you just need to download the zip file. This is the last version, the MiG 360. When you download this file, you have this zip file here. What I need to do, I have a virtual machine here. I will just run a little example how to use this tool. So basically, I just download to my machine and then I'm moving to this file here. I will move to my virtual machine. Let me access this new machine. So here is the file. Of course, if this machine has internet connection, you can just download directly to the machine. But just to let you know how it works. Let me create a new directory here. So what I have here, I have the MiG360 SH. This SH will run for every database in this server if you have more than one database, or you can run directly the SQL on the specific database. So let me show here. You can run this tool using a user with the data dictionary access, but I recommend you if you can run as a DBA user, especially the sysdba, because you have more information on the tool. Basically, you need to run the MiG360 and pass some parameters file. For example, you have on the GitHub, you have the explanation how to use the tool. The first parameter is if you have the non-diagnostic or if you have diagnostic and tuning pack. In this case, I have both, so I'm seeing I have the tuning pack. The second parameter will be if you are planning to run the ESP, it's a tool from Carlos Sierra to do consolidations. For example, if you are planning to move, like you have 10 databases and you are planning to consolidate these 10 databases in just one server, you can run this tool to check this. So now I'm not running. The other parameters are optional, so the tool is already running. So it will take a while to run. It depends on your database size and on your AWR retention. So I have one file that I run previews on the same machine. So let me copy this file here to not wait 20 minutes until the tool finish. So when the tool finishes, the tool will create a zip file. The name of the tool, your database name, and date and time. So I move it to the same directory. Here is the result for the tool. You can unzip the file. I think the virtual machine is consuming a lot of my resource. Okay. So when you open this, you have this is 0001. It's the main file for the tool. But let me start from some files that you have on these two. For example, you can go here and you have a quick DB view and your database name file. When you open this guy here, you can see the most important information about your database. So why I created this tool? Because I'm working as a consultant, and when we have some work to move database, the customer used to approach and ask us the same question every time. So I need to move my database to cloud, and I need to know how long it will take and how much it will cost. And every time I need to send a lot of questions to the customer. For example, I need to know your database size, your database version, the SO, how many concurrent users, and everything. So I developed this tool. So you can download this tool to send to your customer. The customer will run the tool, and you have all the information you need to plan the migration. So you don't need to do a lot of calls with the customer to ask a lot of questions. So you have everything you need on just one tool. So basically, first thing I do, I open this file to check the database, all the information. For example, I know the database name, version, block size. I know the number of data files. I know if it's a single instance or rack. I know the database memory, SGA, PGA. I know the number of CPUs. I know the SO. I know the patches applied on this database. I know the information about PDBs. I have the memory information here. I have the session information, number of sessions connected to this database. And I also have the weights. So I can have an overview of the database, just to open one file. Another thing I have in this tool is this file here. For example, I have the DDL to create new users. So if I'm preparing the new database, I just came here and copy the DDLs to create the table spaces and the users. This one is for the table space. So there is no new table spaces on the database. Why? This is why we are not seeing any new table space here. Another file you have here, it's a CSV file with all the information you need to build the migration scripts. If you need to build a migration script that is not in the tool, you can import these informations on your database and build your all script. So let's go back to the most important. This is the most important file, the index. This is how the tool looks like. So in this screen, what I have the database name, the license that I use to run the tool. And I have the AWR retention. By default is 8 days, but on this database is 31 days. So I'm seeing 31 days of information on my database activity. For example, I have my system under observation. Let me explain some things here. The look and feel for this tool, it's the same look and feel for all the tools we used and we create on the Enkitech. It's based on Mode 369. It's a free framework created by Rodrigo Jorge. So all the tools you see from Enkitech guys, you see the same look and feel. System under observation, this is my first link. It's basically the same I have on QuickDB view, but in this format. I have information about database instances, pluggable database. For example, I have my database properties. So if I'm planning to change my character set or anything, I can see what I have in production. Good thing I can see here, for example, I can see my database parameters. So I have all the parameters, so I can check before I move my database. I have the modified, I have all. I have hidden parameter changes. I have parameter file for PDBs, for example. I have schedule information. So before move my database, I can see all the jobs running in this database. I can check the maintenance task. For example, I can see if I have my statistics collection or any other maintenance task active. I have information about patch, for example. This is using the O patch. I have the same information here, but it's using this view. Sometimes I prefer to use the O patch to see all the patches in my database. And I also have the option to see the patches for my grid infrastructure. Of course, this is not a ASM database. This is why I don't have the information here. I have information about memory, SGA, PGA, and memory. I have also the advisor information. Maybe I need to adjust this before move my database. Resource. For example, I can see my database consume on CPU. For example, I can see how many CPU this database is using during my AWR retention. I can see memory. I can see, for example, database size. Here I have the total database size. I have some good information. For example, I have the IOPS and MBPS. For example, I can see if my shape in the Oracle Cloud will be okay with this number of IOPS and MBPS. Another thing very useful and important, feature usage statistics. For example, I can see all the features in use for this database. So it's very important to choose the database version I'm going in the Oracle Cloud. So I can go to the enterprise high performance or extreme performance based on this information. What else? A lot of information. I can see if I have valid objects. I can see, for example, logon triggers. This is very important if I need to create these logon triggers on my new database. I can see information about my table spaces, data files. This one is very important. For example, I can see my top largest object, so I can start to thinking about partition my tables before move. I have information about ASM. I have information about backup and recovery, everything I need. I have information about the user profiles and privileges. I can check before create these users and move. I also have the information about the resource manager, if it's created. This is very important. I have information if I have, for example, SQL profiles and SQL plan baselines. I need to consider if I will move these guys to my new database. For example, if I'm moving using data pump, just moving the schemas, maybe I can have some performance problems because I forgot to move these guys to the new database. I have information about statistics, result cache. This is very good. For example, I can come here and see my sessions. For example, if I create a new database, I can come here and see all the machines connected to my database. So I can go directly to these machines to change the TNS names or the connection strings on this machine. Because if I forgot to do this in one machine and I move to a new IP address, I will have a problem for clients to connect to my new database. I have data guard information, Golden Gate, if this database is running Golden Gate to extract data. I have information about, for example, SGA and PGA. I can see some anomalies here to fix before move. I can see also my time model. I have some information based on my history. For example, I have the same information here for session, but based on my history. So in this part, I have the information current connected to my database, and this is from the history. Another good thing I have here is, for example, top SQLs. I can came to this guy here, and I'm seeing just one SQL taking 79% of the database time. So if I came here and fix this SQL, I can move my database to the Oracle Cloud and use and pay less CPU. So it's a very good point when you are thinking to move your databases to first fix your top SQLs. You have your network information, for example, SQLnet configuration. I have information about the listener and everything. Sometimes we do some changes on the SQLnet and we forgot this part when we are moving. I have also the cron tab jobs and information about the SO. And the best part, I have the migration options. So, for example, if I'm planning to move using the data pump, let me open a new file from a better database, because this is just a VM. So let me open this. This is a more realistic database. So for example, if I'm planning to move using data pump, I can go to the tool, and the tool will provide you all the information you need to move your database, all the steps. So I can just copy and paste, and I have all the steps to migrate my database to the Oracle Cloud. So all the steps you need to move this database. And you have a lot of options. You can use, for example, using data pump, you can use recovery manager. For example, if I decide to create using a data guard, the tool will generate for you all the steps you need to do to create your data guard. For example, if I need to plug and unplug, I have all the steps. I just need to copy and paste, and I will have my database migrated to the Oracle Cloud based on all these options. And if you find any options you need and it's not in the tool, you can also use this file here to import all the information on your database, and you can create your own migration script. So you are 1 minute. So let me stop sharing, and thank you guys. If you have any questions, we have 1 minute or otherwise you can just send me an email or contact me on
at the moment, just one, Zabala. Thank you, first of all, for your great presentation. What's the best? The better. What's the best to use? No, it's best to use zero downtime or manually migration, in your opinion.
Well, it depends. It's the zero migration tool from Oracle. They are talking.
Yes.
Yes. The tool it's very good. It will do everything for you. If you are planning to use, it's working for data guard option. If you have the option to use data guard, if your database it's Linux and you are moving to the Oracle Cloud and using the same database version, you can go and use this tool. It's very nice and will automate everything for you. But if you need to do any kind of migration, for example, AIX or Solaris to any other, to Linux, for example, you need to do manually.
Okay.
Okay, I think
I have some blinking on Zoom. I think I am back.
I think we are 1 minute later, so
Okay.
I think
So,
we can go to the next speaker.
yeah, thank you so
for
much,
1 minute later.
Zabala. And thank you all guys to join us today. And the next speaker will be my friend Mariami Kupatadze.
Hello, everyone. Can you hear me?
Yes.
Yeah. Hello, I will start sharing and then we'll talk. Okay. So first of all, thanks to the LuxOUG team for giving us the chance to have these virtual days and technical days for speakers and for attenders. Today we will explore the database architecture, which is important to know, and most of the senior DBAs already know about that. Otherwise, administrating the database would be more complicated. But for the junior DBAs, I think these slides will be very useful. This is a small paragraph about me. I am Senior Solutions Architect at FlashGrid, Oracle Certified Master, Oracle ACE Program Member. I'm a co-writer, and we have recently published a book about Oracle Golden Gate with microservices, where I'm a co-author, and on the second book, I wrote only one chapter, Oracle Sharding. On the right side, there is my contact information where you can send any questions, and I will be more than happy to answer. The last one is my blog where I share my knowledge about Oracle and Linux. So we'll not talk more about myself. Let's switch to the topic. Objectives are the following. So why I chose this topic is that, like the doctor knows the anatomy of the human body, and based on some symptoms, he or she can analyze where the disease is and cure the actual disease as soon as possible. We database administrators are also doctors for Oracle, and we should know all the components of Oracle database. So let's switch to the next slide. There are three major architectural structures in Oracle database: memory, processes, and storage. So when we think about the instance, we know that it consists only memory and process part, no storage included except during startup phase when it reads the parameter file. When instance starts, system global area is allocated and background processes are started. So this about the instance. On this picture, I depicted this simple architecture, how client and database connection works in a simple way. So when client connects to the database, client of course knows database IP address, port number, and name. And there is a network access, of course, open. Client sends the packet to the database server process, and what happens now is the user process is started on the client side. The corresponding server process, if it's dedicated server environments, a server process is started on the database side, which has a program global area, the area which is not shared by other server processes. And database is responsible to return the result of the client, but it needs some components to work simultaneously and in synchronously. So system global area, background processes, storage are responsible for analyzing the data, parsing the SQL statement, and returning the output to the client. So next slide shows us two types of systems. It's not related to Oracle. Mostly we have such systems in other databases and in other architectures. The first one, simple one from where everyone starts, is non-clustered system, where we have one node which has some sort of storage attached, and database is located on the storage. When database starts, SGA and background processes are allocated to the on the node. So for one database, for ORCL database, we have one instance also called ORCL, and for HRDB we have also one instance which is mostly same name, HRDB instance. But in clustered environment, we have a different configuration. We have at least two nodes. We can have one node cluster, but this is the purpose of one node cluster is that in the future you aim to add more nodes. So mostly when we think about the cluster, real application cluster, we think at least two nodes. They have a shared storage where the database files are located, and when database starts, first instance is started on the first node and second instance is started on the second node. For ORCL database, we have two instances here, as you see on the picture, ORCL1 and ORCL2. This was the simple illustration. Connecting to the database, two main concepts we should know about the connection. First is a connection, which is a communication link between user process and server process, this one. And session is a specific connection between user and instance. Regarding the memory structures, we have two main areas in Oracle database: system global area, SGA, and program global area, PGA, which itself are divided into small pools or caches. And we have two types of memory management: automatic shared memory management, where we set memory target to 0, and we set SGA parameters explicitly and PGA parameters. where we define the sizes of each component, globally SGA and the PGA. I should mention that PGA aggregate limit was not available in 11G. It's became available in 12C, and this is actually hard limit of the PGA. And before 12C, we are setting PGA aggregate target to some value, but sometimes our Oracle database may exceed the specified value, because this was just the target, not the hard limit. For automatic memory management, we set memory target and memory max target parameters, which itself will distribute dynamically memory for the SGA and for the PGA. What happens here, when we have bigger sized databases, we mostly do not use automatic memory management. We use automatic shared memory management instead, because in bigger databases, we have bigger memory. So we definitely need to use huge pages when the page table contains bigger size chunks, because it's easier to manage by mostly CPU. So if you use huge pages, you cannot use this type of memory management. You need to set SGA separately. So in the next slides, we will just look through all these pools in details. Database buffer cache. The illustration of database buffer cache can be visible as a grid where we have changed and unchanged blocks. With a pink color, I depicted changed blocks, and this gray color is unchanged blocks. It holds copies of data that are read from disks from data files. Okay. In the shared pool, we have also some areas, library cache and data dictionary cache, and also some other areas. Data dictionary cache holds reference information about database and its structures and users. A library cache stores executable SQL and PL/SQL statements. It also contains the statement parse tree and execution plan. For example, when one client runs the statement, let's say select start from hr.emp. This statement, if it's the first time not in library cache, and Oracle needs to hard parse this statement, set up the parse tree and execution plan. This plan is placed in this library cache, and next time when the same user or another user tries to run the same statement, Oracle need only search the corresponding statement in the library cache and use its execution plan. So this is called soft parse, when CPU resources and other resources are more released and easier for Oracle. That's why we need shared pool. Read log buffer is a circular buffer, which means when it's filled, it's rewritten again. It holds information about changes done by data manipulation language or data definition language that contains redo entries later to recover instance in case of instance termination on some or some other cases. So when the client runs, let's say, update statement, this update statement is written in the read log buffer. Large pool is used for allocation of big chunks of memory, such as used by parallel query and RMAN operations. Sometimes we use Java code in the database, and we need for this to have Java pool set accordingly. If we use streams, Java pool stores all session-specific Java code and data within the Java virtual machine. And streams pool is not commonly used. Mostly we do not use streams, and Oracle also recommends us to use Golden Gate for application purposes. Because with bigger data, streams is not the good option. For capture and apply, if we still use for some small tables, we need to set streams pool accordingly. For the fixed SGA, this is not changeable. All other buffers and pools are changeable through the parameter. Fixed SGA, it contains state of the database and the instance background processes. It's like a bootstrap section where SGA, which saves information about other parts of the SGA. The PGA is a program global area specific to an operating process or thread that's not shared by other processes. And this is also divided into several areas. SQL work area, this blue one, and the private SQL area. When we have some sort of operations like selecting something and we have order by statement, we need sort area size to use, not we, but Oracle uses. Hash area is used for hash joins, and bitmap merge is used when bitmap indexes need to be merged to retrieve data. Persistent area contains bind variable values. Runtime area contains query execution state. How many rows retrieved so far? User process on the application. So we have in the process architecture, we have user process, database process, daemon, and application processes. User process, as you described, is started on the client side. Database process is started on the server, on the database server side, and we have two types of database processes: server process and background process. Server process, when user establishes a session, server process is started on the database side and connects to the instance. Background process, as we've seen before, is responsible for reading the data from disk and writing to the buffer and vice versa. Application processes and daemons are network listener, grid infrastructure daemons. So what processes we have in Oracle? To describe the illustration, when a user process connects to the database, server process is started, but how the connection happens? We have another guy here. This is the listener, which listens on some endpoint. This is the IP address of the a public network and some port number, listener port number. When user connects to the listener forwards to the database node. Then the connection happens after finding the server process and allocating the PGA. The connection happens to another link. So why should we know this? When we stop the listener, we should know what effect does it have on the database. If we stop the listener, no existing connection will stop. Existing connections will continue to work because they use separate channel for communication, but no new connection will happen to the database. Let's look through all these required and optional processes, background processes. Database writer writes dirty, so changed blocks from buffer cache to data file, disk, and also reading from here to the buffer. we have N here because there may be several database writers. Log writer, as you guessed, is reading the data from read log buffer and writing to the read log files. And this happens on some schedule when user process commits a transaction. So when transaction is committed, we are sure that the transaction is saved in on the disk, because in previous slide, when we update the block, it may not return to the data file every time because this operation is very heavy and requires a lot of resources. So Oracle delays this writing to the data file, but as we know, if instance terminates, this buffer is cleared, so we need to have that information saved on disk permanently before commit returns the notification to the client that transaction is committed. The information from read log buffer goes to the read log files, and later, if our instance crashes, instance recovery happens automatically by Oracle by reading all changes after latest system change number, and Oracle starts. Another option, another schedule is when log buffer is 1/3 full and before database writer writes modified blocks to disks, or every 3 seconds. Checkpoint process is very important process. It records checkpoint information into the control file and data file headers. Checkpointing is an important Oracle activity which records the highest system change number. So when commit happens, system change number increases, so that all data blocks less than or equal to the system change number are known to be written out to the data files. If there is a failure and then subsequent cache recovery is needed, only the reader record that containing changes higher than the checkpoint need to be applied during instance recovery process. System monitor is responsible for performing recovery at instance startup and cleaning unused temporary segments. Process monitor performs process recovery when a user process fails. So when user is connected and something happened, for example, network disruption happened between the client and the database. This user, of course, had some resources allocated. If it changed something, then buffer cache is also not clean and contains changes done by this user, but maybe these changes are not committed even and not ended successfully. And also it may have some logs. So process monitor is responsible for cleaning up, identifying such a process first, and cleaning database buffer cache, which was only the part which was modified by this user, frees resources by the failed user process, releases logs, monitors session idle timeout. Why process monitor needs to see and check session idle timeout? Is that when user connect to the database, mostly we have some idle timeout set by default 15 minutes. And after if the user is not running anything, so is not active for 15 minutes, its idle timeout is passed, and session should be disconnected. The connection should be dropped. When the user reruns some statement in the same session, it will get error, and process monitor should clean up or should do all these tasks mentioned before. In lower versions, it was dynamically registering database service with listeners, but in newer versions, now it's done by LREG process, listener registration process, not process monitor anymore. A recovery process, RECO, is used with distributed database configuration. What is distributed database configuration? Let's recall, this is let's say transaction. One part of the transaction is running on the database 1, and another part of the transaction is running on the database 2, and only after that comes commit statement. This mostly is achievable through the database links. But what happens if the database 1 transaction fails? We need to have someone responsible for the task to clean the second part of the transaction on the remote database. This is in-doubt transaction because the first part of the transaction was not finished. So Rico is responsible to connect to the second database several times and automatically connect and resolve in-doubt transactions by rolling back them. Archiver process is optional because it's not always available. If you have your database in archive log mode only, then you will see archiver process. It copies, of course, redo log files to the designated area, storage area after log switch, and can collect also if you have data guard, can collect the redo data and transmit to the standby destination. Why do we need to archive this? Because as we know, log files are circular. So when one is filled, it's switched to the another, and when last is filled, it's switched to the first one. And if first one is not archived, it's rewritten. If you are not in archive log mode, it's rewritten and you will lose some data. For point-in-time recovery purposes. Database physical structure is a control file, is a really important file which contains database file location, online read log file location, temporary undo tablespace file. I mean, it's data files actually, temporary and undo files. Also contains information about database name, system change number, database ID, backup information, but it's limited in size and backup information may be rewritten. So we need to have a recovery catalog for saving backup information in the database instead of control file. Data file contains actual blocks and actual data. Redo log file, as we've talked, contains changes like update statement, delete, create, and any other DML and DDL statements inside the read log file. Read log file may not contain the data if you run some direct pass operations or some operations that has indicated no logging, but sometimes this operation may still go to the redo log file because maybe your database in data guard and the forced logging is enabled. We have two types of parameter files, as you know, a system SP file, and which is binary, and parameter file, which is text file, which contains all the parameter information about the database, instance specific parameters, the memory values like SGA target, PGA target, and so on. Also contains information about the control files, control underscore file, parameter contains that value. And several other parameters which is critical for the database. Control file, data file, and current redo log file is critical for the database, but we can recreate the parameter file. We just may lose some parameters and we need to retune our database, but it's still recreatable. Backup file is the copy of the data file. Archive log is a copy of the redo log file. Password file contains information about administrative users. Why do we need this file? Because when database is stopped, we still need to connect to the database. And if the password is saved inside the database, then we won't be able to connect because it's down. So we need some external file for that. Alert log and trace files, also incident and core files mostly are for Oracle support, and these files is very critical for the database administrator, and we regularly check and also have some notifications and alerts set to watch this file. It contains chronological order, the log files in a chronological order, and when something happens, this is the first place where we check what's happening in the database. Now we've talked about physical. Now let's talk about the logical structure and also see where they intersect. In logical structure, we have database. Database consists of several table spaces. Table space can be located on several data files if it's small file. This file is physically located on some storage. Table space consists several segments. Segment actually is a table, but it's not abstract thing. This is a table index. It's a partition table, then several partitions are several indexes and so on. If we have some size for the table, for example, 20G table, and we need to add more rows, then we need to, Oracle needs to increase segment by some size, and this some size is extent. Extent is a combination of Oracle data blocks. So let's see another illustration of the same. Segment exists in table space, as we know. Segments are collection of extents. Extents are collection of database blocks, and database block itself is a collection of file system block, operating system block. This illustration depicts several things together. First of all, we see that we have table space, two types of table spaces, small file, which is default, and you can have multiple data files if you want to increase the size of the table space, and we have big file. This is not default. We need to indicate keyword big file during the creation. We can have only one data file in big file table space, which size is 128 terabyte maximum. In small file, we have several files which consist of database blocks. I've chosen 8 KB. This database block cannot be changed without recreation, but you can have additional table spaces, additional sized blocks, but default cannot be changed. Here I've chosen 8 KB, which is most common for most of the databases. Several combination of blocks consists extent, and as you see, one extent is located in one file, another extent is located in another file, and the sum of these is a segment. So we are not sure when one file goes offline what amount of data we lose from the table, let's say. Maybe all the extents are located in this file, or maybe none of the segment extents were located to this file and only this file and some other files. Important table spaces, we have system, which is always online when database is open and contain the data dictionary tables for the database. SysAux table space is the auxiliary table space to the system table space, and this is a centralized location for database. Also, Enterprise Manager repository saves the information inside this table space. temporary contains temporary data and may contain data for sorting operations. If you remember, I've mentioned sort area size, which is located in the PGA, SQL work area, which is used sorting operations. And when you run some select statement, which has ordered by clause and there is a big amount of data, and these data should be placed for sorting in the sort area size. If this size is too small, then our data goes to the temporary table space. So on the disk, and sorting operation happens there. So that's why our order by may be too slow if our sort area size is not big enough. Undo contains undo segments. So for the insert statement, undo is delete. For the delete statement, undo is insert. For the update, undo statement is the same update, but with the reverse changes. So to recall the phase when there is instance termination, what happens? First of all, database comes into no mount state, reads a parameter file, then goes to the mount state, reads control file. Then it reads data file, system change number, checks that it needs recovery because control file knows that the database are not up to date. It reads the redo data until the end, applies these changes, and if there are some changes that was not committed and the redo still contains this one, then undo is necessary at the last phase to undo all the uncommitted transactions. If you have any questions, please feel free to ask. I will wait, and also I have some small questions, like 6 of them we can test on our environment to see how it looks like. Let me know, and meanwhile I will share my another terminal, another screen. Do you have any questions? I think this topic was not new to everyone, and I hope if you don't have questions, so you already knew these things. Just let's play with the database.
Sorry, Mari, I have some problem with Zoom. My screen became black again.
Oh, okay. So while you are solving your problem, I think there is no question in the chat, so I will just continue my question and answer section. So the first question can be how to check parameters in Oracle database. What are ways for that? The first one is to show the parameter, for example, for HGA max size. Let's connect to the database and run this statement. This is my parameter, this is my value. Or another version of checking is checking dynamic view with our parameter and selecting and filtering by name HGA max size. How to set size for database buffer cache. as we know, there are some parameters that can be changed dynamically, or some are static parameters and they cannot be changed in the memory. So we have two scopes, right? Memory and SP file. If we are changing parameters that cannot be changed in memory, then we need to explicitly specify scope SP file. Otherwise, the default is both. Both means memory and SP file. So after setting this, outer system set and DB cache size, we're setting 300 megabytes. It's altered, but actually not active right now. Database needs to be restarted. I will not restart now, not necessary for the illustration. How to check where my data files and vlog files are located. So let's check this through the data dictionary view. This is DBA underscore data files. We have another also. Let's check that the file name column contains that, or select name from your data file. So if we need to know members of the log, then we check in that log file. So simply, if we want to know where my control files are located, then we can check in dynamic view $control file. Or checking the parameter control file underscore control underscore file. As we talked, SP file and parameter file also contains information about the control file as a parameter. So this one. How to check what is the maximum PGA usage after instance startup. So when instance starts, we have define some parameters for PGA and SGA, but this may change for a while, and it may be not necessary that much size, and you need to adjust according to your environments. We have several statistics, dynamic views with changes every time we can monitor, or also we can do this not only through this way, but from the cloud control or some other tools to check our memory parameters and statistics of the Oracle. For example, this one will show us what was the maximum PGA allocated in this database after instance startup. This is instance specific. I'm checking on the real application cluster, but actually I'm selecting only instance related information, and will show you the information about this, the first instance. Show parameter, check which instance is that. Number, the first one. Or the simplest one, how to find what is the OS process ID of my DB writer or log writer. We can run some commands from here, and if we want to run Linux command, then we need to write this exclamation mark, and we just check processes and grab the DB writer. So this is our database writer 0, the only one database writer for the ORCL database. ID is this one. And for the log writer, ID is this one. So background process contains the name inside, so we can easily identify where is the log writer, where is the database writer, and so on. And some of the processes are restartable if you kill suddenly, or some other process, for example, during the out of memory, the kernel may kill some processes, and one of them may be the database, writer or log writer, and it may cause instance termination. So be careful with killing processes. For example, if I kill system monitor, you know what happens, right? Instance will be terminated. Okay, I talked too fast in this session. Let me know if you have any questions, not to the session related, maybe some other questions related to Oracle.
I have one question, but just for curiosity. What is the often static parameter that you forget doing to the installations?
Which parameter, static parameter?
What is the most common parameter you forget to set during your installations, static parameters? For example, in my case, I very often forget to set convert to set up data guards. So when I realized that, I said, oh my gosh.
Oh, really? Yes, and you need to restart the database. Yeah, I've had the same situation several times. Where I work, actually, we do not do too much manual stuff. We did a lot of automatic scripts. So mostly we add automation. So we do not forget. That's why.
Yes, that's good.
Everything is scripted.
Automatize scripting. So once you
Right.
fix it, you fix forever.
Right, that's right.
Any more questions? Let's see. Sorry, my Zoom hung twice. Once when doing the last presentation with Zabala, and now with you. When you finish, you start to asking. I was trying to reply you, but I don't know if you heard my voice.
Oh, okay. Now it's perfect.
So thank you so much, Mari. I hope I pronounced your name correctly in the beginning of the presentation. That time I correct the name. Perfect.
Thank you too. Everything was really great. I attended other sessions and they were really interesting and very, very good stuff. So thank you again.
Thank you so much for everybody, and also the speakers from today and the previous days. And tomorrow we'll have the last day of fun on LuxOUG Virtual Tech Days this week. So maybe we will have more events in the future, but this week will end up tomorrow for us. So thank you very much for everyone. See you tomorrow if it's possible. Bye-bye.